You guys have something to watch. Axiom 1 is live.
Ready for Axiom 1 for the early part.
All right, I'll put that on, dude. You guys tell me if you hear anything.
Launch, Crew 3 landing at the end of April, and then OFT2 in May. And when I got into space operations, it was for these missions, and man, this is just a really super exciting time right now. So 6 months ago, because I know this is going to be one of the questions I'll get, so I'm going to answer it right now. So 6 months ago, I remember Jim Free and I were looking, and we were like, oh man,
I'll be right back.
Artemis 1 wet dress and that first private astronaut mission are going to be like right on top of each other, and everybody could ask me, what are you going to do about that? And I said, we're not going to be in the same place, so don't worry about it. Don't worry about it. Don't worry about it. And so here we are 1 week before, and guess what? Artemis 1 wet dress and the Axiom 1 mission are on top of each other. So I will tell you right now, Artemis 1 wet dress has the range. You know, our plan is to get that done as early as possible. But our plan also is, I think we've all as a team been through this before, that we still got, 8 to 10 days of processing on both sides for us to get there. So they're getting ready for their wet dress, but we and the Axiom and the SpaceX team are also getting ready to be able to launch as closely to April 3rd as possible. And so we're working through that, and we'll continue to monitor. As from a station point of view today, when we were going through our flight readiness reviews, obviously we're looking at getting this mission off and not impacting our Crew 4 delivery of crew to the International Space Station. And so that was a major topic, and we feel like we got a plan for that, and we're going to go execute to that plan. As our first private astronaut mission flight readiness review, it was really important for the team to think about how do we do this and the scope of it, and make sure that we had a careful focus on ISS safety and making sure that the ISS program was ready to accept this new vehicle and conduct all the work. There's a tremendous amount of work being done on the International Space Station during this period of time with that crew, and so we wanted to really make sure that we were ready for it, and everyone polled go. One of the other things I wanted to say is this is really a pathfinder for us. So it's important for us to take these missions and learn from this mission about how we can do better. And so as a team, as we get through this mission, we learned a ton heading into this mission. The team's done a tremendous amount of work getting ready for today. We're going to learn more conducting the mission, and then we're going to collect all of that learning. And after we're done, we're going to roll that back into us being able to do this operation even better than before. So with that, I look forward to hearing your questions. Thank you.
Thank you very much, Kathy. We'll now go to Dana Weigel.
All right. Thank you, Gary. Thank you, Kathy. Let's see, we had a really great flight readiness review today. The Space Station team is really excited to have this private mission so close to flying. As I think you know, we've been working on this capability to do private missions for many years, and we're ready to welcome some new visitors on board ISS. We're happy to be part of and on the leading edge of helping to foster a new LEO economy. As Kathy mentioned, it's been really busy on board, and we've got a busy spring in front of us. We just finished 2 spacewalks, one last week and then one this week. Mark Vande Hei returning on the 30th. He'll be the record holder for the longest single space flight by an American with 355 days on orbit, which is pretty impressive. The onboard crew is also getting ready for their Axiom crew visit. When Axiom arrives, they'll do some of the standard things that any one of our crews would do. There are a handful of handovers and briefings like safety and emergency equipment familiarizations, and then there's kind of general on-orbit familiarization, learning how to live and work in the microgravity and space station environments. Once they get settled in, they'll start doing their core mission activities, which include a combination of human research, technology demonstrations, outreach, and some commercial activities. The Axiom crew is doing a lot of research experiments through the ISS National Lab. It's a really unique opportunity to have Axiom be able to open up the world-class research capabilities of the station to a whole new user community. That's pretty exciting for us. There's a lot of new experiments. There's a lot of new investigators, a whole different kind of user base, if you will, who's participating with Axiom in this mission. This mission also provides some unique opportunities for NASA and for the station program. We're partnering with Axiom to return 2 of our freezers that'll have critical frozen science samples in them. That's always a precious commodity for us. We tend to get a backlog on orbit. They'll also be helping by returning a really large air tank for us. And then, as Kathy said, right after the Axiom mission, it's right back to a busy time frame, launching and docking Crew 4, doing a abbreviated handover, 5-day handover between those 2, bringing Crew 3 home, and then turning back around about a week and a half later for Boeing's OFT-2 mission. So very much look forward to the mission. Our teams have been working really, really hard and looking forward to it. And with that, I will hand it off.
All right. Thank you, Dana. We'll now go over to Angela Hart.
Hey, thank you to everyone who's participating today. I want to let you know I'm extremely happy to be here reporting our readiness to move forward with the launch of the X-1 mission coming out of a very successful FRR. This mission represents a significant milestone for NASA's goals to build a robust commercial economy in low Earth orbit that was mentioned before, and it specifically helps stimulate demand as part of NASA's overall vision for long-term sustainable commercial presence in low Earth orbit, with NASA astronauts able to work side by side with both private and international astronauts. It represents a first of many commercial missions we have envisioned in the future. The agency recently announced its selection of Axiom Space to begin negotiations for a second private astronaut mission with NASA, and we are also making great progress for future commercial destinations needed to be available for NASA for services post-ISS. In December of 2021, NASA announced its selection of 3 companies, Blue Origin, NanoRacks, and Northrop Grumman, to develop designs for commercial space stations in low Earth orbit, adding to the contract previously awarded to Axiom Space in January of 2020 to design and develop commercial modules to attach to the ISS. Axiom recently completed their preliminary design review of 2 of their modules, as well as critical design review of modules' primary structure with NASA participation, and Blue Origin recently conducted their systems readiness review and are closing out that work for their orbital reef. Flight hardware for the first Axiom module is currently under fabrication, and we are very happy with the success of these, all of these companies as they leap forward in designing potential commercial destinations for our future. It's been a lot of hard work to get to this point, and I'm extremely impressed and proud of the NASA, Axiom, and SpaceX teams for the achievement that they conducted today, leading toward this very important milestone. Thank you very much.
Thank you, Angela. Let's go over to Mike Suffredini.
Good afternoon. As a company, it would be an understatement to say that we are excited by where we are at this point for this historic mission, the first fully commercial mission to the International Space Station. And for us, it really is the first of a series of flights, precursor missions, before our station comes to orbit the first module will come into orbit in the latter part of 2024. And so this really is paving a way for a new era where there are more and more opportunities for individuals and nations around the world to live and work in the microgravity environment. We couldn't be more proud of the crew. It's an international crew. Michael Lopez Alegria, he's an ex-NASA astronaut, but also a Spaniard as well. Pilot Larry Connor is a U.S. citizen. Our mission specialists are Eitan Stebi of Israel and Mark Pathy of Canada. Impressive still for this crew is the fact that each of them have decided that what they really want to do is make a difference for all of us here on our planet Earth, and as such, they've decided they wanted to conduct research. So working together with many research institutions around the world, we're set up to conduct in excess of 25 experiments during their time on orbit, conducting over 100 hours of research during their 10-day mission. Their preparation was equally impressive. They've had over 700 hours of training in preparation for their mission. They've exceeded all the requirements put forth, doing extra work to make sure they were ready to go, and I couldn't be more proud of them. Today, the crew is in quarantine, waiting for the chance to go. It's reasonable to say they're chomping at the bit to go launch. They're doing the last-minute preparations that you normally do, getting ready to go fly, and we're prepared to support the launch dates as Kathy mentioned earlier. I would like to say in closing that nothing gets done in human spaceflight without a very big team, and the Axiom Space Company would like to extend our appreciations both to SpaceX, our transportation provider, and to NASA, who's going to take care of us while we're on orbit. So thank you guys very much.
All right, thank you, Mike. Finally, we'll head over to Bill Gerstenmaier.
The FRR today was really thorough, and as I think has been discussed earlier, this is a very unique mission and really the first flight of private citizens to the ISS. And Axiom, NASA, and SpaceX, we all play a unique role in this first-of-a-kind mission. You know, and it's, again, amazing the teamwork and the way we put things together. In terms of SpaceX, our job is to get the vehicles ready to go fly, to deliver the crew to and from space station, and both Falcon 9 and Dragon are ready to go do that. The crew is trained, the ground teams and the hardware, they're ready, pending some final task completions. We have a pretty busy weekend in front of us. We have hypergolic loading going on in the Dragon capsule for the Axiom mission. We're also getting the Crew 4 Dragon ready to go fly, and it's over in the Dragon processing facility also being processed. So it's a pretty exciting time for us, seeing 2 Dragon vehicles in final processing, both getting ready to go fly within just several days of each other. And an amazing time, including the landing. And again, I think this is a really important time for us. It's an incredible responsibility for all of us. You know, human spaceflight's unbelievably humbling and difficult, and we must always listen to our hardware, not get focused on schedule. We need to listen to the data, learn real-world lessons, and make sure we're ready to go fly safe. And I think today's review showed that this team's ready to go do this, and we're ready for this exciting period. So I'm not sure how it's going to all unfold, but I can tell you we're ready to move forward, and we'll see how it comes out over the next several days.
All right, thank you, Bill, and thanks to all of our briefers for those initial remarks. We'll now open it up for questions. Again, if you're on the phone bridge, press *1 to submit a question. Once your name is called, please state to whom you'd like to direct your question. We'll expect a lot of questions, so if you find that yours has already been answered, you can always press *2 to withdraw it. So let's go ahead and start on our phone bridge with Elizabeth Howell from space.com.
Oh, hi. Thanks for taking my question. This one is for Kathy. You were talking earlier about how there are so many human missions that are going to space, and then we also talked about this little bit of a traffic jam situation that's going to be occurring. And so I just was wondering where everybody's going to be managing this in the future. You know, SpaceX, Axiom, NASA, everybody else is using those ranges.
This is a good problem to have, right? So we're going to have to, obviously there's a lot of communication going on now, and we're going to have to keep talking. But it's a good problem to have.
Thanks for your question. Let's go to Jeff Faust with Space News.
Hey, good afternoon. To ask about the schedule, just curious if the wet dress rehearsal goes ahead on April 3rd, and you slip the Axiom 1 launch, I would assume at least a day, to April 4. Does that have sort of a domino effect on the schedules moving out for, like, Crew 4? Is there a day-for-day slip if Axiom 1 slips to Crew 4, for example? Or at some point do you shorten the Axiom 1 mission to keep Crew 4 on track for a mid-April launch? Thanks.
No, you should do it, Dina.
Yeah, right now we've actually got a little bit of buffer there, so we've got a kind of a launch window, if you will, a number of attempts that we can do with the Axiom mission before we have any implications to having to move Crew 4, so we've got a handful of days there. At some point, we will have to kind of move Crew 4 day by day, and one of the bigger variables actually for us is once the mission gets up there, and it's a 10-day total mission, 8 days docked. So once they dock, 8 days later, we'll go to undock. And as you know, weather is a big variable for us. And so even though on paper you could look at it and say, well, I should be able to launch, this many attempts in a row before I hit my 4:19 start target for Crew 4, I think the real key will be getting off as early as we can. We'll want to take those early opportunities, assuming we have good launch weather, because we don't know what we'll get on the back end for the undock, and so that can present variables to us in terms of how long it takes for Axiom to undock.
We're all going to become I can already tell how many daily weather sessions that we're going to be having. I can already see it happening.
Very good. Let's go to Ed Ludlow with Bloomberg News.
Hey, thanks for doing the briefing, guys. I guess for Kathy and for Dana, again, kind of similar to the last question, but there was a bit of confusion about the releases and blogs that went out today. So is April the 4th likely? And then you talked a bit about Artemis, Kathy, and juggling this, but has Mark's return been a factor? And will there be any significant changes to protocol given that it's Soyuz, Kazakhstan, and everything that's going on with the conflict in Ukraine?
No, I think the team is proceeding to go meet Mark at the landing site, and undocking or landing still happening on March 30th, and so that's proceeding nominally. Right now you have to pick a vehicle, and so we're with wet dress there, really having the Artemis vehicle there, get their tests done, and then really allows us then to have this series of launches, launch opportunities for us to be able to get off. And so, obviously, like we already talked about, we've got a series of work that we got to do. Both programs are doing hypergol loading. Actually, we'll be doing hypergol loading over the weekends, and we'll be doing various other checkouts. And so if an opportunity opens up for Axiom 1, let me tell you, we're going to take it. But I do think getting the wet dress done and then allowing us then a series of launch opportunities is kind of the smartest thing for us to do. So I think right now, obviously with them, they actually are holding schedule, doing really well. I probably will be ready by the 2nd. Probably still be holding the 3rd with the other activities we have going on at the range. And then we're going to be set up right there to be able to start as soon as we can, weather permitting, obviously, from the 4th on. But like Bill talked about before, there's work to be done, right? This is the time where you set a date, but you got to keep watching your hardware and making sure you get everything done right to get there.
For your question, let's go to Marcia Dunn with Associated Press.
Hi. This question is for Mike Seppardini and someone for NASA. I'm just wondering, how much leeway will the crew have once on board the space station? Are they going to have, will they use their own discretion on where they can go, what they can do, and is there any sort of list from NASA of don't do this or don't go there, or any hard, fast rules like that? Thanks.
Yeah, Marcia, thanks for the question. The crew has been trained on the systems they will need to interact with, including the research systems. So they're fully trained on that. They're also trained on what not to interact with. In addition to that, of course, Michael Lopez Alegria is a professional astronaut. He has been gone back and gotten a remedial training, bring him back up so he has a full understanding of all the systems on ISS, and so he's also there to help out, make sure folks understand. But they're very well trained on the systems that they're supposed to interact with, to utilize those independently, and they're equally trained on what not to interact with.
Thanks for your question. Let's go to Chris Davenport, Washington Post.
Hi, thanks. Actually, just following up on that, because I was curious, does the crew have any plans to work on the Russian segment of the station? Are they allowed to visit the Russian side if they wanted to? I'm just wondering what the rules are when you have private citizens coming aboard the space station. Thanks.
This is Dana Weigel. I'll take that. That's a good question. We actually have bilateral agreements with all of our different partners, and so even though this is new to us to fly private citizens, as you know, the Russians have done it on a number of occasions. In fact, they had 2 missions, in the fall and in the winter of last year, and so the arrangements that we have is each of the private citizens and or their representatives can make agreements with different partner agencies if they choose to do so. If they haven't done that, in this case, Axiom doesn't have specific, agreements for activities on the Russian segment, then the way we handle it on board, it's by invitation. And so if the crews want to share a meal, they'll invite each other over. And so it's very much managed by the onboard crew and what activities they have going on and if they'd like to visit in each other's segment.
All right, let's go to Irene Klotz, Aviation Week.
Thanks, Gary. Kathy, can you go through the decision points of when SLS wet dress would go ahead versus Axiom preps? In other words, if SLS folks get to call the stations on the 1st, at that point, do you stand down till they're complete with detanking? And maybe Bill Gerstenmaier, if you might chime in a little bit about what you're able to do at Pad A when these things are going on at Pad B, when you'd have the hot fire for the Falcon 9. I assume you're doing one. Just trying to get a better sense of how you're going to integrate this wonderful problem you have.
Well, there's heading into this period, there's like daily meetings between Charlie Blackwell-Thompson, the range folks, the SpaceX folks, the folks doing these missions to integrate all their activities, right? This is kind of what we do day to day out of the range. And so definitely Jim Free and I have been talking about, the priority across from a mission per mission perspective and what kind of makes sense, just to make sure that we're also synced up on decision points. We were going to do a checkpoint on Monday just to see how the vehicles were coming through the weekend and where things make sense. So I'm kind of telling you where we are right now. We're going to look at things again on Monday. I think from a planning perspective, it made a lot of sense to us to just get the wet dress mission done, them being able to start their data, and then letting us have the time, the successive launch attempts then for the Axiom 1 mission and then heading into Crew 4 and working those missions. It lets the Artemis team be able to go do that data and the reconfiguration and then begin, getting ready for what's going to be a really historic launch in June. So, but every day we're working and coordinating, along with the team at KSC that's making sure you got consumables and people, we do launches and we don't realize there's all these people out there that really make it happen, making sure we have commodities, making sure you got the right support at all the different areas. And so there's people working to make what sometimes looks pretty easy happen for us. The easiest part of the decision is just us talking and making sure we're coordinated, right? So, thanks.
And I just add to what Kathy said, our 2 launch directors, the one on the SpaceX side and the one on the NASA side, they're talking daily. There's a lot of shared resources between 39A and 39B, and they coordinate daily to make sure we get an optimum schedule for both of us. And it's amazing how well the teams can work without adult supervision from above. If you just give them the basic guidance, they go out, figure out how to go do things, and actually can accomplish pretty amazing things by self-integrating. So we're letting the launch directors figure out how to make this work and give us the best schedule back, and they'll report to us on Monday, and we'll get a chance to see how the weekend work came on both sides and make some decisions, and things will become clearer as we go through this process.
Sometimes it works better when we're not in the middle of it.
Thanks. It'd be really awesome to have a daily status report as this as these schedules unfold.
We'll look at making sure we keep our blogs and stuff up to date, and that you got information out there. I know that that's a big deal for you guys.
Great questions. Let's go to Bill Harwood, CBS News.
Yeah, thanks, and good afternoon. What is the minimum separation between wet dress T0 and the AX1 launch, and what drives that? And for Dana, if X1 doesn't go on April 3rd, what are the backup dates? You mentioned a handful, but what are they? And what's the cutoff date before you impact day for day Crew 4 and Crew 3 return? Looking for some specificity. Thanks.
So the big right now, the big impact, or not the big impact, one of the big things you need that kind of drives separation right now for between the end of wet dress and us getting ready for Axiom 1 mission is actually commodities. For us to inert the Artemis 1 tanks, it's a huge rocket, right? And so for when here after wet dress, when the engines when they're detanking, they have to make sure that you've got a bunch of GN2 to be able to inert the system to make sure that we're keeping the structure safe, because obviously we got a big mission coming up. Well, that takes a load. If you talk to Charlie Blackwell Thompson, she would be able to tell you how many GN2 trucks have been coming in to get us ready for the wet dress. I think we've got GN2 trucks lined up outside of KSC for this, getting ready for this wet dress. And so the key thing is we got to get that replenished then to be able to go do our Axiom 1 mission. So I know the team's working that really hard. I think for a little while it looked like there was about a 2-day separation. People are working to make that shorter, so that potentially if we get wet dress off on the 3rd, maybe we could launch on the 4th, but we're still early days in it, and I liked Irene's idea of as we're working through it, we'll start sending out, daily updates for you guys so that you guys know where it is. But really right now it's really about consumables.
All right, let's see, and to answer the second part of the question you had about the launch dates, as you know, right now Crew 4 is on the 19th, and we need 2 days between the undocking of Axiom 1 and the launch of Crew 4. So if you look at that and back it up with an 8-day docked mission, it means we could launch on the 7th, and if we had perfect weather for undock, which, as you know, that's not necessarily in the highly likely category, could happen, but not necessarily highly likely. Then in theory, you hold the 19th on paper. After that, we end up with essentially a day-for-day slip, but again, keep in mind that the undock is really one of our big variables also, and so, it could take you a few days to try to undock. And so we've got a little bit of capability also on the Crew 4 side in terms of what we can accommodate on board station and still do the handover and the Crew 3 return and the rest of the back end of April-May timeframe.
So I'd say, we're pretty clean. Still, we're pretty clean for launches up, I would say, up to the 8th or 9th, right? I think we're pretty clean up to that point, which gives us multiple attempts and looking at successive attempts for us to be able to get that launch off. We'll be watching weather, I'll tell you, and then looking at the mission and what's the right time from a weather perspective and what does that mean. On the back end, we'd like to start on the 19th, but then we probably, we can start going for the next week to try to get that launch off and still be able to accomplish what we need to do. The key thing is we have a high beta that starts on May 10th that we really want to get Crew 3 off before that high beta. We're also starting to look at how far you could go into the high beta and get the vehicle off, but As you know, we're continuing to look at kind of our margins, but I think we've got 6 or 7 days to be able to get Axiom 1 off. We'll be looking, like I said, at the weather to make sure we look at how we're going to work the 8-day mission and then our return options, and then we've got 7 or 8 days there to be able to get crew 4 off, and so I think we got a decent chance of getting all the missions done.
Great question, Bill. Let's go to Stephen Clark, Spaceflight Now.
Thank you for taking my question. Can you hear me?
We can hear you.
Thank you. I just wanted to clarify a couple of things. I think Dana mentioned up front the OFT-2 mission may be a week and a half or so after the Crew 3 return. I think that was penciled in for May the 20th. Is there any discussion of moving that up a bit, and if so, by how much? And also wanted to ask about static fire for AX-1. What's the scheduled date for that, and does that static fire factor into planning for the commodities constraints with the LC-39? Is that a factor in when you can do the WDR and then when you can do the AX-1 launch? Thank you.
So static fire is the first. So SpaceX is doing the Transporter 4.
Yep.
Transporter 4 launch.
Transporter 4 launch on April 1st, followed by static fire, and then in the morning is dry dress for the Axiom crew. So April 1st, we have 3 activities: dry dress for the crew, and a short break, we go into static fire, and at the same time, we just prior to starting the count for static fire, we complete a Transporter 4 launch off of Pad 40. That's the current plan.
Yeah, what I was really referring to with the week and a half was the same thing Kathy mentioned in the previous question related to the high beta, and so the no later than when we'd like to get Crew 3 undocked is by the 10th of May, and with OFT-2 on the 20th, that's where I was talking about the week and a half. Of course, Crew 3, our nominal plan is to undock it earlier, but that's just how far we could move it to the right if we needed to.
And the high beta time frame is that 10th through the 19th. So that's why we're kind of blocking off that time period. So we wouldn't be able to pull up OFT2 that time frame because we typically don't have the dockings during the high beta event.
Thanks for your question. Let's go to Jim McKenna, Aerospace Tech Review.
Thanks very much. This is for Kathy, I believe. I understand with this commercial mission that Axiom is responsible for crew and passengers during launch, ascent, return, and recovery, and then NASA will take over once they're within the integrated operations range of station. In general, how complete are the procedures for approving a commercial mission to ISS and later to free-flying stations, and who's sharing the responsibility for finalizing those procedures?
Are you talking about procedures or are you talking about plans? Definitely the procedures for how we're going to do this, all of our planning for the mission has been audited, reviewed. Angela Hart out of our CLD group, the program, and the station program have been working with Axiom on all the activities that folks are doing on orbit, and making sure that it kind of falls within the NASA guidelines for the activities we need to do on the station. And then obviously Axiom is responsible for the activities that they're doing within their module and the pre-flyer spaces. I think one of the big learning that we've had out of this whole process is how to work together and do that in a way that we can get it done and make sure that we're both meeting our guidelines and responsibilities. And you did a great job of summarizing each of our responsibilities. you know, it'd be great to figure out how to do it faster, and that's definitely one of the things that we'll need to be working on, but we're learning a lot by going through this process. I don't know, Angela, if you wanted to add anything, or Dana.
No, I think you said it exactly right. I mean, we have worked really hard with the Axiom team and ISS in order to ensure that we're meeting the requirements on the NASA side and the guidelines and the policies, but still allowing Axiom to meet their visions and goals for their company and their business plans. And so it's been a real interesting activity, and I think we've come to great processes, plans, and solutions on a lot of different challenges that we had as we were pulling this together, and we're going to continue to learn more and as Kathy said, be able to do this better and faster and possibly even offer different and more opportunities as we move forward and learn more about how to work in this commercial arena.
Very good. Let's go to Richard Dribeau for Orlando Sentinel.
Hi, this question, thank you for taking it. It's for Michael, and I'm looking at your future missions, crew missions. This mission is an 8-day on station. Are you looking at working with NASA for longer, and specifically as you're prepping to add your individual components to the station, are you looking to keep a member of Axiom Space on board for longer periods? Thank you.
Thank you. Yes. First of all, our second mission, I believe that was mentioned by Angela. Our second mission has been approved, and that one is also a shorter duration flight. We do, when we look to the future, have progressively longer missions. Our third mission wants to be about 30 days as our fourth mission does. And then by the time our module arrives, don't hold me to this because we're still deciding, but either once we get our first module fully activated and checked out, or more likely once we bring up our second module, which will double the capacity for crew, and it adds 2 more. With those 2 modules, we'll have 2 more docking ports added to the complex. We do intend to go to full-time on ISS with at least 1 Axiom crew person, but we will also bring customers along on those flights as well.
All right, thank you. Let's go to Rachel Crane, CNN.
This question is for Michael. Sorry about my voice, guys. I'm a little under the weather. Michael, you mentioned that the crew has conducted, over 700 hours of training, but can you give us some context of how that compares to professional astronauts? And can you give us a little more insight into the training? What parts of the training are not necessary for, this commercial crew compared to professional crew? Thank you so much.
Let's see. I can partially answer that. On the International Space Station, we do really the total amount of time we spend training the crew for the systems is extremely limited compared to the professional astronauts who do really almost something in order of 45 weeks of astronaut candidate training, followed by then flight-specific training once they're selected. So many weeks and months of preparation, and our crews do something like 4 or 5 weeks of total. I'm sorry, something like 8 weeks of total training on the ISS. The other half of our training is done with our SpaceX friends, and while we do endeavor to train to the same level as our NASA colleagues, I'm not sure that we do all the way up to that, but maybe Bill would know.
Yeah, we're basically training the Axiom crews to the same level we train government astronauts for operations of Dragon for the portions that they're doing. We also do a lot of integrated simulations where it's kind of unique in the fact that some of the search and rescue capabilities are provided by Axiom through their contractor, we did some integrated simulations where we actually worked with the crew to go through that entire end-to-end activity to make sure the crew would be safe during the ascent in the case of a drag and abort. So the training is very thorough, and in terms of what we train them in terms of dragging, it's basically the same as we're training our government astronauts.
Let's see, from a NASA standpoint, if you look at our government astronaut training, whether it be NASA or one of our ESA astronauts or any one of our international partners, they have pretty extensive training. Of course, as they're on board, they've got to deal with and interact with all the systems on the spacecraft, whether there are issues in a European module, a Japanese module, one of our modules, and so their training is very extensive. In a lot of cases, there's a lot of preventative maintenance and work they have to do to keep things well-tuned. There are a lot of corrective things, and then there's a lot of other complexities, whether it's a specialist in robotics or spacewalks, so a lot of other ancillary things. And so there's pretty extensive training for the government astronauts. The training for private astronauts is really based on their mission, so it's very much focused on the types of activities they're doing for the mission. Of course, safety is paramount, and so the safety training, emergency response, for example, is trained very much like what we would train for a government astronaut. But beyond that, it's focused on daily living, food preparations, how to deal with the water system just for getting, drinking water, use of cameras and videos, and then, of course, the research equipment that they're planning to use. So it's very much tailored to what they're using. They, of course, are not expected to respond to issues on the spacecraft or to deal with correcting something. If the toilet won't flush, we'll go and use one of our government astronauts to go and deal with that. So a little bit of a difference there in terms of the responsibilities and the types of things they're doing and training to do.
Your question. Let's go to Micah Maddenberg, Wall Street Journal.
Hey, everybody. Good evening. Mike, a question for you. You mentioned the second mission. Could you talk a little bit about customer demand? How many sort of missions to ISS could you organize right now? Does Axiom have a waiting list or sort of deposits down from future customers? And if so, could you kind of quantify the number of people that may be on it? Thanks.
Yeah, we're in various states of signed customers and those that are have offers. An offer really is a preliminary agreement to go sign a contract. It just lets us go ahead and hold the flight while we work through the contract. And then the number of countries, and they're a little bit different. But if you look at the first 4 flights we have lined up, AX1, 2, and 3 are done in terms of who's flying, and 4 is 4 has it. Two are identified and signed. There are 2 that are seats that are open on that flight, but we have other customers that are asking to fly on them. So, we're flying. We'd like to fly a little more often, but the demand is we're meeting the demand as it is today. I will say though, after the first flight, we would expect. Well, we know that there'll be several customers ready to sign. They're kind of waiting to see what happens with the flight, and it's just like anything. Once you do something the first time, then there's a little more excitement in the system. So we would expect demand to pick up.
Question. Let's go to Gina Sinceri, ABC News.
Hi, I want to follow up on Bill Harwood's question. I'm a little confused. What is the launch window and what are the times that you're looking at for launch for AX1?
Okay, so if we go on Monday, April 4th, it'll be at 12:50 p.m. Eastern Time. If we go on April the 5th, it's 12:27 p.m. Eastern Time. And I promised Irene we'd send out daily, and we're going to hold. I'm looking at my folks here. We've EDI'd at them. We'll be sending out dates for all this information, so you guys don't have to be hunting around for it. Okay. So we'll get that out for you all. All right. Thanks.
Go to Jeff Faust, Space News.
Thanks for the second question. For Bill Gerstenmaier, I'm just curious if you have any updates on the investigation into the lagging parachute you saw in a couple recent Dragon splashdowns. Are you planning to collect any additional imagery or other data for the Axiom 1 splashdown? Thanks.
Yeah, we took a really extensive look at the lagging parachute. We reviewed all our developmental tests, all our flights, and it's interesting that some cases it's not obvious that we even have a delayed or lagging parachute. It's only a couple seconds, and you can't even see it in the video. You don't even detect it. And then if you look at the descent velocity and you just had the data and you didn't have any cameras, you wouldn't even know that the parachute was actually delayed. Even these ones that delayed 60 and 70 seconds, you wouldn't even see it. But we went through all that and we couldn't find anything that stood out as a contributing cause. We looked at all the reefing line cutters that cut. We looked at all the lines. We did detailed reviews of all the parachutes and the packing. We didn't see anything that's there. So our kind of conclusion is that this 4-parachute system, based on its descent velocity and the amount of air that can actually inflate the parachute, has the potential for a parachute to lag. So it's not unheard of that even on this Axiom return, we might have another lagging parachute. And if we do, it's just a function of the design. We're fully certified to land with just 3 parachutes. We're continuing to look and see if we can find any reason why one delays and another doesn't. We can't find anything other than the fact that it's at the altitude that we're deploying, at the time we're deploying, there's maybe the other chutes actually take all the load, and then that doesn't, the 3rd or 4th parachute doesn't really require to take much load. So the capsule operates perfectly normally, and we show that 4th lagging parachute will always inflate typically before we land. So we spent a lot of time looking at that, trying to figure out if there was anything we were missing. We can't find anything. I think it's almost a feature of this design, but we'll continue to keep looking, continue to keep monitoring. But I wouldn't be surprised if we don't see it again in some of the upcoming flights. And we also have, NASA provides the WB aircraft to get pictures. We've also increased the video quality, so you won't see in-cabin crew video during return. We're actually going to dedicate higher bandwidth to the cameras on board Dragon, so we can actually get better looks at the parachutes and see more details. So we're continuing to work this. This is something we want to understand. When I talked about being hungry and looking at safety and what's the hardware telling us, this is something that's telling us, and we didn't discover anything that causes us any concern, but we're going to keep looking and keep watching.
Your question. Let's go to Elizabeth Howell, space.com.
Hello again. We just wanted to get some clarity about that date that Kathy was mentioning about Artemis 1 potentially launching in June. Could you please clarify that late May is no longer on the table and which June window you're going to aim for, if that's going to be early June or late June?
Well, I kind of feel a little uncomfortable because this is a Axiom 1 mission, and I'm going to get in trouble at Jim Free. So I think right now that's a great question for us to take for the Exploration Systems Directorate to answer. Right, and they also, we got to get through wet drifts just like we got to get through all the other different phases, and then I'm sure they'll be talking about it after wet drift is done. But we'll get you a response with the latest date that they have right now. I just don't have it off the top of my head.
Let's go to Stephen Clark, Spaceflight Now.
Thank you for taking another question. Just wanted to ask, I think the AX-1 mission at one point was assigned to a different spacecraft in the SpaceX fleet, I think to Resilience, which flew on Inspiration 4. Can you talk about the reason for switching to Crew Dragon Endeavour, and also an update on the refurbishment of Crew Dragon Resilience and the cleaning up of that contamination from the toilet system, and when
mission. If you remember, we flew the cupola on the Inspiration 4 mission. We need a docking mechanism, so it was actually easier to go ahead and leave the capsule with a docking mechanism, not pull the cupola off and then put the docking mechanism on. So we don't really see it as a capsule switch that other folks talk about as a capsule switch. We were always planning on using one without the cupola and using one that had a docking mechanism and moving forward. In terms of the cleanup of the capsule, we had the 2 vehicles with potential corrosion. They both have been cleaned up and they're both ready to go fly. We did a lot of work to remediate those vehicles and make sure that we've got that problem behind us, and those vehicles and the weldments will be ready to go support the missions in the future.
All right, let's go to Ed Ludlow, Bloomberg News.
Thanks for the additional question. Bill, it's kind of similar, but you guys also have a lot going on in a small time window. How are you managing the kind of roster of Falcon 9s? And I wondered if you could talk a little bit about the similarities and differences between an Axiom trip to ISS and what the build-up was like to Inspiration 4. Is it very similar, or are there some key kind of differences in the two?
Again, I think the key thing is they're both crew missions, and we treat crew missions very differently than we do our Starlink missions. On our Starlink missions, we'll push new changes in, we'll push new hardware, we'll actually push the limits of the rocket. We're actually changing some of the thrust characteristics of the rocket to actually get more performance out of it. And that actually gives us information that helps inform the crew mission. So we actually know where the margins are. We can actually have a safer vehicle for crew missions. I would say in terms of the launch, they're pretty similar. In the case of Inspiration 4, we don't have to go to a rendezvous point. We don't have to go dock with the space station. So we had the degree of freedom that we could launch almost at any time we wanted to. But the problem there is because we weren't going to space station, we had to then be able to return within the amount of time that Dragon could stay in orbit. So Inspiration 4 was unique in the fact that I had to not only set a launch time, I also had to set the return time at the same time I launched. So I had to look at weather both for launch and for return. So that's very different than station. When you go to station, you get the luxury of you can stay on board station until the reentry weather gets perfect, and then you can come home. In the case of Inspiration 4, where I don't go to station, it was a much more difficult planning time, but I had the degree of freedom. I didn't have to launch at any particular time of day. So if you saw that mission, it occurred at night, so that was a time of kind of the optimum weather that set us up for the landing moving forward. So each one of these missions are unique. The teams do a really good job of balancing all these constraints, understanding what they are, and putting together the right mix to go accomplish the mission we want. And we've got separate folks and separate teams that support these things, so we can support multiple Dragon activities at once. We can support multiple Falcon launches. You know, we've been launching Falcon flights roughly about once per week for the first part of this year. That's, again, a tribute to the teams moving forward. I think we've had 11 flights in 11 weeks. So that the teams are pretty good, and that launch cadence also helps us really get ready for the crew flights. So when we go into a crew flight, we don't have maybe as much sim time, but we have actual flight time, and that really helps our controllers be ready and be sharp and be ready to go do what they need to go do for the flights.
Thank you.
Okay, thanks. I think we have time for one more question, so we'll pull it from Mary Liz Bender, Cosmic Perspective.
Hi, thank you so much. Just a little more on the differences between the Inspiration 4 and this AX-1 mission. You know, during Inspiration 4, I think the public was extremely shocked by how spoiled we've all been with all of the NASA missions. You know, typically we get to see the crew in the cabin. We get a lot of live stream footage of all of the activities, including, you know, in orbit and then docking and undocking. And I'm curious if we can expect the same from this mission. And I'm sorry, I should have said that was likely for probably Bill or Michael.
So Mike, maybe you can address what's going on with Axiom.
Yeah. So from your perspective, this will look a little bit more like a normal, I'll call it normal ISS launch. The crew will arrive. We'll do a crew arrival ceremony. The cameras will be on about the same throughout as you're used to, and we'll have a departure ceremony. So all those things you're used to seeing on an ISS crew flight will be similar for our flight. And Bill can tell you about the Inspiration 4 flight.
Yeah, I think what we really do is we kind of respond to what our customers want. And if they feel the need to go do activities, we'll support those activities. If they want to do some more private things or it fits better with their mission plans, we kind of support whatever the customer wants.
Okay. Thanks to all who submitted questions, and thanks again to our briefers for taking the time to discuss the upcoming mission. That'll do it for us. As mentioned, we'll do our best to provide updates on nasa.gov. You can always go there for the latest information regarding the Axiom 1 mission and the other missions we're doing here at NASA. Thanks again for joining us. That'll wrap up today's briefing.
Turns out inhaling water is bad for you. Here, let me try to inhale more. Wait, you aren't a fish? No, not that. Any gills? Okay. Welcome to Space News. That was the Axiom 1 press conference. Interesting. So, you know, wrong pipe is not good for if you have to speak a lot. Excuse me. You know that water goes down the other pipe. Oh, I know. I don't. The esophagus.dll has failed or something. Okay, so the Axiom mission is a I'm just gonna wait for it. It's a all-commercial flight to the ISS. So think Inspiration 4, but going to the ISS. It is commanded, set throat to SCE. Try SCE to aux. There we go. So, actually, those are a lot of interesting questions. They're targeting early April. There's a lot of stuff happening next week at KSC, including the wet dress rehearsal for the Artemis 1 mission. There's dry dress. There's a dry dress for Axiom 1, and I think there's another Starlink too. There's a lot of stuff going on down there at the Cape. It is quite busy. Let's see. Let me take a look. So, yeah, Transporter 4. Yeah, that's what they were saying. They were saying Transporter 4 on the first. Actually, we got 2 launches on the first. Oh, wow. What's the first? Well, that's going to be a long stream. Yep, that's going to be a really long stream. Okay, I'll take that under advisement. And then on the third, they have the Axiom 1 mission. Supposedly, that's when they're going to do some wet dress rehearsal tests, sometime early in April. 4-1 to 4-3. Wow. Wow, next week is nuts, Novus. Jeez. And then there's the next Starlink on 40. Man, there's a backup on Starlink. Jeez. 2-week turnaround. And then there's another Falcon 9 on the 15th. Look at this. 1, 2, 3, 4. 4 Falcon 9s in the first 2 weeks of April. Okay. And then 39A needs to be turned around right away after the Axiom 1 mission. Dude, 2 back-to-back crew launches on 39A. Not bad. Not bad at all. Falcon 9's a beast, man. It's a freaking beast, dude. I've said this. I've saying this for a little while. You know, that whole Starship thing is fantastic, right? But SpaceX would be like, SpaceX is like way ahead of the curve compared to everybody else. Like, just with Falcon 9, let alone that frickin' thing. Like, that's a lot. I was distracted. They say that SLS has to get off the pad before the AX-1 mission. Nope, they can do simultaneous operations. It's fine. That was actually one of the press questions. That was a really good question. I mean, Deadbringer, it's a beast, dude, and you got to remember, just because Falcon 9, like, it's a revenue rocket, it's a revenue system, right? No, dude, every time they launch it, it gets cheaper. Like, it's not. The booster core serial numbers are going in the 70s up now, so they've made 70 different Falcon 9s, dude, and then however many freaking upper stages, dude. I lost count of the upper stage serial numbers. They went well into the hundreds. Like, it's almost like into the 200s, man. Hawthorne is just cranking out upper stages. Think about it. Think about how many upper stages they need to manufacture. It's not just about reusing the first stages. The factory has to be in overdrive. It's probably the busiest it's ever been. They did increase their prices a bit because of inflation on Starlink and on Falcon 9 launches. I mean, 7% inflation will do that. Yeah. It'll raise the price on things like housing prices. Emotional damage. All right, anyway. Serial production of upper stages. Yep. And on top of that, OneWeb. It's going to be crazy. How's that going for you? It's going all right. My boat. Yeah, no, it's not bad. I got a line on another house. Like, Acton, it's not that the houses don't come on the market. It's that they come on the market and then they're gone. They come on the market and then they're gone, and then they go for like $100,000 above asking. So, great. Yeah. So, I don't know. I'll find something. We'll figure it out. Hey, we might have to end up moving out in the sticks. And if we move out into the sticks, that's not a bad thing because that means it's going to be cheaper. The problem is we're just out in the sticks. I might have to end up buying something like Starlink, dude. I might not have a choice. I don't know. Do you think that Starlink is good enough to stream from? Like, what's the upload that they get from Starlink? It can't be as good as my upload here. This is a gigabit fiber optic, man. It's not. The internet's fantastic. Like, I have Verizon, and it is fan-freaking-tastic. Literally zero downtime. The downtime is like 0.01%. Have you tried being rich? Well, Arfigo, not to hit that right back at you, but that really is that's really something that's up to you guys, and that's not up to me. Yeah, I have a business line installed, Yark. Don't talk to me about bad internet. I'm using an antenna pointed at a radio tower. One of the perks of living in the city, I guess. Get really good internet. I don't know about Starlink, but on Viasat, the planes I manage, I get a whopping 6.5 megabits per second down and 1.5 Mbps up. Oh, 6. 35.5 is all you get? Jeez. I'll run speed test, guys, but I don't want to show you because it shows the IP. I'm currently, keep in mind, this is while streaming in high definition. I'm getting 800 down. And 200 up. 800 down, 200 up, while streaming in high definition. And Brimo's watching a stream as well. Yeah. Yeah, this connection's sweet, man. It's really freaking good, and believe it or not, it's cheaper than Starlink. Just saying. But then again, Starlink is not designed to compete against connections like this. BRB going to EJ's place to game. Zero, you could come over and stream in high def and play GTA with me while I'm streaming in high def playing GTA. Well, Brimo is watching a stream and we're torrenting something legally, and it wouldn't put a dent in this connection. This connection's boss, man. It's really good. I'll probably try for Starlink when it's available there. Is Starlink available in Massachusetts, Mutter? I don't even know. See. But is your LAN set up to handle that traffic? Yeah. Yes, it is. It has to be, Ein. I'm streaming and gaming from 2 different computers. Think about that for a second. Synergy, my program that has the mouse and keyboard. I have 1 mouse and keyboard that's controlling 2 computers. That's through the local area network. Yeah, the LAN's good, but are they on the same switch? Yeah, they are. I do remember some input lag when I tried to play Xbox One on my computer through a linked service. So there might be but the Xbox was through Wi-Fi, and I'm hardwired. My router is right there. I have the whole router and everything right in my office because, yeah, I need to know if the internet goes down. But anyway. Wow, that's terrible, Acton. Jesus. Okay. What is this? I'm not going to get clickbaited on it, but what is that? Bill, that ain't bad for you, for where you are. Bought a 737? Give me 1 second. All right. You have my attention, guy. What's Buff? What's Mike McBrien? Who, I don't know this guy. What are they up to? Check the new Vice script. He's on the TV show Ice Pilots. They do cargo to the Canadian North. Dude. That's a 737. It's got no engines, though. Seriously. That's really freaking cool. That's really cool. That's really neat. I'm happy it's not clickbait. Alaska Airlines Buffalo. I wonder if Acton, do you think they'll put the gravel kit on it? That didn't look like a 747 100 or 200 or 737 100 or 200. Hold on, let me see. Let me take a look at the cowlings again. Nope. That's a 3 or a 4 or something else. It's got the upgraded cowlings on it. They're gonna have. You're gonna have to convert this back to a 200 for the gravel kit. So, okay, we'll put this into plane trivia. 737s rolled out with a gravel kit from the factory. Some of them did. They're super old versions though. It's actually really cool bit of plane trivia here. So check it out. Take a look. There's a 737 that's designed to land on gravel. Yeah, see how it has the super low bypass engine right there? And it's underneath the wings and stuff? Instead of like hanging out in the front? Let's see if I can get a good picture of theirs. See how it's like hanging off in the front? That's for a much later version. These newer versions didn't have that. That one though, that one can land on dirt. It can land on dirt, it can land on gravel. It has reinforced landing gear. You got a skid up in the front. And there's that thing. See that right there? It's a 300 SF. Wow, sweet. Good eye on me. So what that is a little air hose, like compressed air. It's a bleed. It bleeds off of the engine and it shoots air at the ground to keep the dust away from the intake. It's actually really cool. It's a really smart idea. Stephen YG, what did you say? When did you start streaming? Do you know the year and month? Yeah, December 23rd, 2012 is when I started streaming like every day. Started doing it during Christmas break. And yeah. 2012. December 23rd, 2012. Yeah. I played, what did I play? I had done streaming before that, but that's when I started to make it a regular thing. I first streamed in like September of 2012, streaming StarCraft 2, because it was 2012 and StarCraft 2 was really cool, and I thought that would be a cool idea to stream StarCraft and to show the process of someone learning how to play. Right answer, wrong formula. And then Kerbal came out and I decided, I'm like, oh crap, I could do that with this game too. And I'll learn rocket science and it'll be really fun. I'll learn a lot more. And then I went professional streaming on September 19th, 2015. That's when I walked out of my job on the loading dock. Not walked out, I put in my 2 weeks. I've been here since the start then. It's been a journey. Huh. Yeah, pretty much. Cool. Yeah, dude, I got a decade under my belt. It's a fun job, dude. Still fun. Even after all these years, I still enjoy it. I still love what I do. Now, I know what someone's going to type in the chat. Well, you like what you do. You're never going to work a day in your life. Well, I like what I do, but streaming is a lot of work. I haven't worked a 40-hour work week since 2012. Yeah. I think my bare minimum is like 50. Yeah, I haven't worked a 40-hour work week in like a decade. I'm on 50, 60. And then during the pandemic, it was like 60, 70 hours a week during the pandemic. Because I was worried people would go insane because I know what it's like to work from home before everybody else did. Yeah, no, trust me. What's that thing that looks like a guide wire on the picture of that 737? I shut it off. A guide wire, that's the antenna. I love what you do. Streams are very informative to me. You have a way of explaining things that works well, even though I'm a little stupid. Steve, why do you think I can explain it so well? Because I need to explain it to myself, who is also stupid. I'm with you. I'm a freaking caveman, dude. DRS is disabled tomorrow? Oh, yeah. Lovely. Did you see the comments about Buffalo Air's DC-3s? I saw some of them checkered, yeah. P3 Orions and whatnot, yeah. Missed my 9-year follow anniversary. Oops. When did you have time to play Master Chief in the new show? Alright, that's the second time you said that. You think I look like... Who's this guy? Pablo Schreiber? Okay. Okay. This image, let me see. Okay. Yeah. Yeah, I see it. Yeah, I see it. Yeah. Yeah, okay. It looks like you, except he's good looking. Thanks. An F-104 keeps flying over your house. Nice. Yeah, okay. I see it. Yeah. Yeah. Yeah, baby. All right, anyway. So, we got a lot of launches next week. Let's see, what else? So, there are some new pictures coming out of Michoud of the core stage 2. Another SLS core. The hydrogen tank was attached to the forward join segment here. So here, let me show you. They took the hydrogen tank from the second SLS core. F1 News. Okay, yeah, I'll check that in a second. So this is the second core stage 2. This one will fly the Artemis 2 mission. It will fly the Artemis 2 mission, which will bring people back out to the moon for the first time since December 1972. That mission is slated for 2024. And there's a shot of them putting the hydrogen tank together. There's the inner tank right there, which is the structural bulkhead between, or the structural cylinder between the LOX tank and the hydrogen tank, and this is the forward skirt. So if you look right there on the inner tank, that's an SRB attachment. Well, no, the booster is on the side. That's a downcomer. The SRB attachment points are up here and up here. Saving to show the orange change over the next 2 years. Oh, that actually reminds me. There's them putting the bolts together. Got to torque it to spec. Ah, yeah, see? Who knows what that is? Man, don't listen to what Chad says. I think you look great. Panzer's just screwing with me, Liam. Do we know the crew for the Artemis mission? We do not, Checkered, no. It's it's static strap. Ground yourself. You don't want to short something on the booster. Cool. Question, why don't they do common bulkhead with hydrolocks, even if you need self-eye on the common bulkhead? It's easier, okay. It's easier to manage the temperatures between your propellants because the hydrogen is like a liquid at -400, oxygen is a liquid at like -300. That's still a 100-degree difference. Yes, that's in Fahrenheit. I don't remember what it is in centigrade. I always forget that part. So you have a huge temperature delta between your commodities on the vehicle. So it's easier just to keep them separated and then just insulate it. Now, with that being said, there are common bulkhead hydrolock systems like the Centaur with its balloon tanks. But it has balloon tanks because it's made out of stainless steel. So stainless steel is going to be a little different. This is stir-welded aluminum. So different materials allow for different pros and cons. You couldn't make a balloon tank at the scale of the SLS core. I mean, you could. It just wouldn't work very well because you have to attach 2 SRBs to the side. And they would rip the thing in half. Which brings me to the second point. The reason why you have an inner tank here is because there's a gigantic structural crossmember that connects the front booster attachment segments. Yep. There's a huge structural beam in here that separates the 2 tanks, and it holds, it's basically helps move the force from the SRBs to the inner tank. SLS is the shuttle, actually, but not SLS so much. The shuttle wasn't so much as flying up with the external tank, but pulling the external tank and the shuttle. The boosters were pulling the external tank and the shuttle up. I mean, you do have your shuttle engines at the bottom that are basically just making sure the thing doesn't fly straight, but the SRBs are doing the majority of the work. They're pulling it up. Same thing with SLS. They're pulling the hydrogen tank. Now, don't get me wrong. It's not all pulling. You split the load, but it's the majority of it is pulling because how force is applied to the vehicle. You have two things at the very bottom right here. They're attached here, 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 and here. The SRBs, when you're pushing up and you have a lot of mass in the center, they'll want to do this. They'll want to push up, so most of the load gets transmitted through the forward strut. Forward attachment point on the SRBs, which once again is right there and right there. It's 12 o'clock on the vehicles right here, so it's 12, 3, 6, and 9. The shuttle was the same way. Yeah, you're pulling the hydrogen tank, partially, because it's hydrogen. It has to be big, and yeah, it can't be at that big a pressure, because hydrogen, once again, there's a fine line between gaseous hydrogen, liquid hydrogen, and solid hydrogen. There's like maybe a 5-degree difference or something ridiculous between gas, liquid, and solid with hydrogen. If you go solid, you're going to have a bad day. Yeah. That's why densified hydrogen really isn't that much of a thing. You have to get that thing super precise to the right temperature, or else it'll either go liquid or it'll go solid. Are you in space? In my mind, chimp. What I don't understand is why they don't lock wiring for all the bolts. They do, Darkness. Yeah, those... Yeah, they do. At least I'm pretty sure. Those must be a special type of bolt if they're not wired out. I know that there's aviation wiring all over the place. So, yeah. It's pretty cool, man. I'm really happy that Core Stage 2 is making such good progress. I mean, in mission timeline speaking, Artemis 2 is right around the corner. Slushy hydrogen sounds bad. Yarg, it's not even slushy hydrogen. It'll either go solid, in which case you hit absolute zero and bad stuff happens, or it'll stay as a liquid, or it'll just turn to gas. Like, there's like a nominal temperature for hydrogen to exist as a liquid. It's like maybe 2 or 3 degrees. That's why it's such a pain in the butt to deal with. You can see the joint between the inner tank panels on that picture with the static strap. Yeah, great pictures. I'm really excited. I'm really happy that they're making such good progress. Okay, what else do we have? Let me look around. All right, let's put that there. There is an interesting article from Science Direct that I think you guys should see. Let me just compile the rest of this stuff. I'm trying to organize it by like what it's about. So we started with SLS, so I'll keep going with SLS here. Let's see, what else do we got here? All right, here. How about you get a little bit of this here? Ow. Thank you for boosting the sound through the roof. I really appreciate it. Here we go. Right. This is coming from Lockheed Martin here. Sloss did another article if you got time. Yeah, we got time. Look. Pretty good. Yeah, there you go, Bright. It's not that much, huh? Can I just... Yeah, there's... Orion, like, solid hydrogen is, like, exists for, like, a second before you, yeah, get to nothing. Man, that's cool. Yeah, that's pretty neat. Okay, alright, that's enough. The real question is, how is it to daily drive? I don't know, man. I'd do it. Doesn't even have a steering wheel. It just has a little tiller wheel. Cue the Initial D soundtrack. Deja vu! I'm pretty sure we have time for the Sloss article, Novus, but wow, that's a long one. I might have to read that one off of stream, unless there's some like super juicy stuff like in there. That's a long article. Wow. Looks like a pain to find a parking spot. Oh, it's got designated parking. You got free parking too. It's not that long. Oh, okay. That's a pretty long one. Anyway, we'll see if we have time at the end of Space News. So this next news, let's see, what should we do? I really wanted to get to the CBA stuff about the Apollo from Science Direct. That's pretty cool. Okay, so there's a thread here from Eric Berger. Let's see what's up here. As Blue Origin nears the critical point of delivering Flight Ready B4 rocket engines to ULA, the engineer in charge of the company's rocket engine program has decided to leave. Okay, we covered this the other day, but let's see. Two sources say that Steve Knowles, the New Glenn program manager for Blue Origin, has also left the company. His departure occurred at about the same time as Vilges. Knowles is well respected inside of the company. I don't know what this means for New Glenn's development. To be clear, this is not the end of New Glenn by any means. Blue Origin is committed to the program, but there's a lot of work yet to be done before it launches in a couple of years. One final note related to the above discussion on New Glenn and its now departed program manager. Two sources say a 2024 debut for the big rocket remains possible, but that a fair amount of things would have to go right, and there remains a lot of programmatic risks. Interesting. Quick question, what game were you playing earlier? What was it called? Planet Creator? It's pretty cool. It's a pretty cool game, Woody Ryder. I don't mind it. Planet Crafter. There you go. That game fell into my lap real quick, which is why I'm like, I don't remember the name. I literally didn't hear about that game as of 48 hours ago. I had no idea what it was. So, Planet Australia. That's right. You know, it's a good game. I didn't mind it. It's a lot like Subnautica, like to a T, so it was really easy to pick up, but it's early access, so we'll give it some time. Like, I saw some pretty good potential with the gameplay loops, how it was playing, but that's because it was Subnautica's. Like, but then again, the game was made by two people. Planet Crafter was made by two guys, from what I understand, or two people. So, who knows? Yeah, Woody Ryder. It seems neat. That was just what our country makes you do for citizenship. Oh boy, Space Australian Simulator. Not sure if you've seen this already. What's this, Isaac? Yeah, I saw that. The blatant misuse of a NASA network switch to get a Halo Slayer match going in the ops room. Yeah, that's pretty funny, Isaac. I like that. Tori said that the engine is performing well, the BE4, and they even updated the capabilities on their website. This is confusing. Guys, all right, so here's the thing, okay? I can't speak for what's going on at Blue, why the guy left. I mean, Eric just didn't say where he moved to. But guys, people move around in the aerospace industry all the time. Believe it or not, it's a very small industry, and a lot of people know each other. A lot of people know each other. Yeah, more than you might think. Like, people know who people are in the industry. It's a weird phenomenon. It's like nothing I've ever seen before. So the reason, okay, why do I bring this up? Well, and how does that pertain to Blue and their New Glenn Direct program manager leaving? He probably got poached. Yeah, he probably got poached. Happens all the time. All the time. Latest official news about the New Glenn launch date. Yeah, the guy probably got poached. He probably got probably applied for a job somewhere and probably got way more than what he was already making at a defense contractor or something. That's how the aerospace industry works. People move around all the time. There's no loyalty to brand. It's not like space Twitter and the spaceflight community that are really like, SpaceX is the best. No, Boeing is the best. No, Lockheed is the best. That doesn't happen in the real industry. No, people don't care. It's about getting paid. Like, and I know there's people that are probably like, what do you mean it's about getting paid? Well, there's that whole eating thing that people need to do. That, and if you shop around like that, you can make a lot of money. Nobody ever said I'm an underpaid aerospace engineer. They said I'm an unpaid aerospace engineering intern, though. Am I right? All right. No. You can shop around, especially if you have project experience, So, yeah, the guy, like, I don't know. Maybe he did, maybe he didn't. But once again, it's Eric Berger, so. And also, two sources say familiar. Yeah, the people moving around in the aerospace industry is something that happens. People get poached all the time. Lauren Lyons was one of SpaceX's commentators. That commentated their webcast. Big SpaceX engineer, and she went to Blue Origin on the HLS, and then she left and went somewhere else. I think she's at Firefly now. People move around all the time. Kind of like Lee Iacocca going from Ford to Chrysler. Yeah, tuning. Take it from me. I'm marrying someone from Dearborn. There's no brand loyalty in Detroit. It really isn't. It's there, but it's not for the people that actually work. Not like the consumers, but for the people that actually work in the automotive industry, they don't give a frick where they work. It could be GM, it could be Ford, it could be Chrysler, it could be Mahindra. It doesn't matter as long as you go where the money is. Like, could be Tesla. One of Brimo's relatives, one of her uncles, worked for Tesla for a long time. Met Elon Musk and stuff, and I talked to him about it. Yeah, that was first Christmas I went to. I'm like, Elon Musk, really? I like that. I'm quite fond of that. I'm quite fond of that guy. He's like, yeah. I'm like, all right. I know him in my dreams. Firefly is reshuffling a lot, Jax, right now. Yeah, they're reshuffling a lot. That Ukrainian guy that they had investing in the company was preventing them from bidding on DoD contracts, from what I understand. So they had to basically separate him from the company to keep the company alive. I know it sounds ridiculous, but I'm pretty sure that's what's going on. I will admit that that's drawing a lot of speculation on my part. I don't know that for sure, but that would make sense. The guy got like sanctioned or something, or he's on a no-fly list or whatever. I know for a fact, I know enough about ITAR to know that they wouldn't be able to bid on DoD stuff if he was attached to the company. I'm pretty damn sure. I could be wrong though. Like, I'm pretty sure that's what's going on. So, Firefly is, they're kind of retooling. They'll be back. Oh yeah, they'll be back. They're fine. Not fine, but it's more, it's not like They fell off the wagon. It's like they took a step back, and then, they took one step backwards to take 2 steps forward later. I'm pretty damn sure. Once again, though, I will say that's my gut. That's gut feeling. I don't know that for sure. I can't prove that. There's no concrete evidence of it, but I'm pretty sure that that's what's going on. I could be wrong, though. By the dip! Yep. 2 sources, like 2 is... Yeah, predominant, yeah, I know. Yeah, Sniper, yeah, I know. It's funny. Dude, I'm telling you, in the industry, it doesn't matter if you work at NASA, you can work at Boeing, you can work at SpaceX, Blue, wherever. It doesn't matter. It's about getting paid. People move around all the time. Yeah. It's not like it is on the internet. It's not like that at all. The industry just doesn't work like that. Everybody knows, like 2 things about the aerospace industry. Everybody knows how freaking hard this is. So everybody cheers each other on. Because of that, and because everybody's, you can love your work, but people are there to get paid, right? And because of that, there's no brand loyalty here. Everybody's excited about everybody's projects. That's what I try to tell you guys. Like, that's what I try to convey. I don't take the hell with taking brand sides when it comes to launch vehicles. We just want more launch vehicles. That's the better thing for the damn industry, man. Oh, I'm sorry. I thought you were a spaceflight fan. Don't you want more rockets and not less? Right? It happens. It happens all the time. So, you don't know that guy wasn't poached. I mean, I don't think Eric would tell you, for all the inside information that he gets. I don't think he would say that. People work to live, for the most part. They don't live to work. Yeah, I like my job, but yeah, I know what you mean. Yeah, I don't know. Does this count as the aerospace industry? I don't think so. I'm sorry, X. I thought this was America. So anyway, that actually brings me to the next thing that I wanted to tell you guys about. It's very interesting. Science Direct here has an improved cost analysis of the Apollo program. I wanted to read this, if you guys don't mind. This seems very interesting. I think you guys would be interested in this. So, let's see. This manuscript presents a high-fidelity reconstruction of the cost of the Apollo program, including year-by-year funding for all major programs and average costs for each crew lunar landing attempt. According to these, the United States spent $25.8 billion on hardware, facilities, and overhead directly associated with the Apollo program between fiscal years 1960 and 1973. Yeah, funny how something in the range of $30 billion keeps popping up even then. Sorry. I know inflation, I get it. This represents a substantial improvement over previous cost reporting. Annual cost data enabled improved adjustments for inflation, which can be accounted for varying inflation rates throughout the 60s and the 70s. This enables comparisons to modern efforts to return humans to the moon, which display a lower and slower cost profile reflecting lower political priority. I do like SpaceX. What's that? I do like SpaceX and the rockets are amazing, but yes, I do want more rockets and stuff for stuff to just move faster. It's been 4 years since I heard about Gateway. What has happened since? Violent, I don't take this the wrong way, but I'm pretty sure you haven't been keeping up with space news. And that's not that stuff hasn't happened with Gateway. You just haven't been keeping up with space news, because stuff is happening with Gateway. They're making the modules right now. But yeah, don't take that the wrong way. Here, I got good news for you. They're building the modules right now. Yeah. Dallas Alinea is working on the Gateway modules. I showed pictures of them about 3 months ago of them being machined. Yeah, a huge turret lathe. It was really cool, actually. They're working on them now. The habitation and logistics outpost and the power and propulsion module are scheduled for a flight in 2024 on Falcon Heavy with its extended fairing. So that's pretty cool. Yep, there you go, Novus, PPE, and Halo. So that's the 2 core modules for the Gateway. They're going to launch them in one piece, which is actually really neat. That's really cool. And then those are the big ones. Those are the big ones. In terms of like not hearing about it, violent. Now, don't get me wrong. Like that's what I mean about you haven't been keeping up with space news. But also, this stuff takes time, dude. Like it takes time. There's bottlenecks all over the place because at the end of the day, you have thousands of people working on this thing, and where like a Gateway module where it's going to end up in a rectilinear halo orbit. There's a lot of stuff that needs to go right to get that to happen, dude. So I want to say, like, in your particular case, it's like half of you not keeping up with the news, which, dude, I don't expect people to religiously follow it, man. It's just space news. Like, learning about space doesn't pertain to your life. You know what I mean? You don't have to know everything about it. So it's like, partially you're not keeping up, but also you got to be patient. You got to be patient with this stuff. Look, even Starship is taking time. And that... programmatic environmental assessment notwithstanding, this stuff, dude, it takes a lot of time. It takes a lot of time and a lot of effort. It's really hard to do. Like, I know that everybody says, oh, space is really hard, but a lot of people don't come up with like reasons why. Well, every little bit of every single part of the spacecraft needs to be individually tested. So if you have 1 million freaking parts, right? You have 1 million parts on your spaceship. Each one of those needs to be tested, and then on top of that, they need to be tested. They need to do integrated testing, right? And guys, keep in mind, what I'm focusing on, this little part, is like one single facet of like the entire scope of a project. This is just during like qualification tests, like qual testing. This is like while you're doing production and testing. Like, you have to test every single one of these components, make sure they all work. Then you have to do all the drawing. Well, actually, before you even build them, you have to make sure all the drawings are good, all the engineering drawings are good, all the ways to put it together, how you're going to put it together, when you're going to attach bolt A and bolt C at the same time. Like, do you do that one first, do that one second? All of that needs to be thought out, because I tell people, like, when you start a spaceflight program or you start a particular project that has to do with aerospace, over here, it's like playing a game of Tetris. You have to stay organized in your mind, because the further you get, the closer you get to like that end goal, right? The harder it's going to get. There's just more stuff to manage. All this different testing, all this different production. How do you, like, okay, so somebody for like the Artemis program, for instance, is playing Factorio right here. Somebody has to think up, okay, we have a core stage that's set to launch. We have an SLS core stage that's set to launch in, I don't know, 2026. Should we start making it now? Do you want to start making it now? Do you want to start making it later? When do we make it? What do we get first? Do we buy the engines first? Do we buy the fuel tank first? Do we buy wiring first? Do we buy pipes first? There's 1,000 bajillion different facets to this. It is extremely complicated. So it does end up taking time. Like, how do you know? How do you know what to get first? What do I get first? I don't know. Maybe we need some better personnel to figure out what parts we should build of our booster first. Hey, that guy at Blue Origin has a lot of experience. How about we poach him? See what I mean? Stuff happens all the time. You just got to hit accelerometers with a hammer. I'm pretty sure they tried that once and it didn't work very well. 2026, I would start making it now. Actually, you know what, Clayton? Believe it or not, a 2026 SLS course should be like 50% manufactured at this point, dude. Straight up. Oh, yeah. I best hope you got the long lead items on that. Meaning like engines and stuff, which is why... And, like, see, NASA knows this, which is why NASA procured all of the shuttle engines through Artemis 12. Because those are long lead items. The engines are the stuff that takes the most amount of time. If you have an engine that takes 6 months to put it together, right? And your core stage takes 2 months to put together, what item do you get first? You get your damn engines first. And then when the engine, hopefully you time it so the engines and the core stage are finished, you can put it all together. And then, like, the first time you go through it, right, might not be the right time you go through the entire engineering process. So the second time around, when you build the second core stage, you're going to take all the stuff that you learned about putting the first core stage together, right, And you're going to optimize the process from there. So core stage 2 shouldn't take as long, right? Wait a minute. Oops. And then core stage 3. The process gets honed down. It gets optimized over time. See what I'm talking about? Look, the second SLS core is already put together, dude. Third one, all the parts for the third core stage, the one that's going to send people back to the moon. That's all the parts of that have been made already. Is that nuts? This is an insane amount of project oversight. Like, it takes time. It's so complicated. Like, and guys, keep in mind, everything that I just said, all of that would be like if you read like a paragraph out of like a 1,000,000-page book. It's that difficult. Like, everything that I just said would be like reading, well, not a paragraph, let me say one chapter of like a book with like 1,000 chapters. It's difficult, man. It's really, really tough. This is hard stuff to do. But that's, like, me personally, Violent, that's why I like it. I like it because it's tough. I like it because the payout is great. When it freaking works and you get it right, that's the best feeling ever. And that's the feedback loop that Kerbal has, believe it or not. When you do something right in Kerbal, it's the best freaking feeling ever. When you do something wrong in Kerbal, it's embarrassing. It really hurts. The third core is already manufactured, Kim. Yeah, it's not assembled, but it's manufactured. Yeah, that's like, dude, I don't need to tell you. You just go look at NASA's images archive. True story. Oh, Violent. When the SSTO blew up on the pad, I felt shame. It really hurt. That was 6 months down the drain, dude. Hurt. It sucks. This is what people mean when they say the long pole in the tent. There's a ton of poles or things happening simultaneously, all which have to happen. The long pole is just the thing that's holding the schedule up, or the tent in the metaphor. Yep. I believe you. Yeah, no, it's built. All the parts are made for it. Dude, they're working. So they're making core stage 4. Core stage 4 long lead items are already procured. So they already have the engines for core stage 4. And Boeing, they took one of the prototype core stages, and that it actually was a manufacturing defect. So the original contract was for, I believe, 2 test articles. So 2 test core stages, right? The Pathfinder, that big steel tube, the mass simulator thing that they moved around in the VAB and moved around on the test stand. So it was for all the parts for 2 core stages. That's the 2 test core stages are like the tanks that they blew up, that they blew all the nitrogen out of and they crunched one in water. That's what those are. I believe there was 2 of those. The Pathfinder, and then there was core stage 1, core stage 2, core stage 3. So that was what the cost plus contract was for. Boeing made the first core stage, and they found that it had a welding defect in it. And they put it off to the side, and then they took what would be core stage 2 and made it core stage 1. And then, through optimized process of core stage 1, 2, and 3, they actually figured out a way to fix that dud core stage. So we actually ended up getting 4 core stages for the price of 3. That's one of the benefits of cost plus. Like, I know everybody's like, oh, cost plus money. I'm an expert in federal funding and economics. No, when you're running a development program, remember I told you that the process gets optimized over time. That's why cost plus contracts exist. That's what they're there for. After we get past 4, then it'll be firm fixed price. And that's when the price of SLS goes. Gateway should launch in 2024, 2025. 2024 is when they want to put the Halo module up there. People on the Gateway should be in 2025. Yeah. COVID shifted everything to the right by about 6 months. We're actually getting 4 core stages for the price of 3, which is nice. We secured stages for Artemis 1, 2, 3, and 4, which is good. That's a good thing. like I said, you gotta block buy these things. Bill's gonna have to do a block buy at some point, but he's building to it. He's building to it. The nomenclature is there. In NASA, which one was it? Which one was it? I forget which bill it was. The nomenclature is there for missions out to Artemis 12, including Block 1B. Block 1B's first flight is supposed to be on Artemis 4, and then Block 2's first flight is supposed to be Artemis 9. That's what it was, yeah. Yeah, it's not bad, Murado. It's not bad. Could be worse. Also, I can't stop thinking if Omega goes around, price goes down even more. Yeah, depends if Northrop Grumman can work on optimizing ways to do that. And if Omega goes around and NASA uses it for, like, launching an Orion into space or something to the ISS or wherever, or a commercial destination or something, yeah. Yeah, of course. Duh. Guys, when it comes to the government programs, remember what I told you 2 days ago? We went on a whole thing about this, about how you have to wind these programs together like a quilt. Got to wind it all together to make it so pulling one thread, if you pull one thread, you can't. You basically can't. You can't just pull on one thread. You're gonna pull the whole quilt with you. That's what the Apollo program did. Apollo program did that on purpose. SLS is basically doing that as well. My only thing is deadlines. You know, it's just a quilt because I wanted to hang a quilt on the wall. It's not a quilt because I wanted to have a blanket and stay warm. No, that's now it is. It wasn't. They couldn't figure out what to do with it because there was, can't, like, getting rid of Constellation, and basically kicking the can down the road like that really is, like, if people want to be mad about SLS, that's what you should be mad about. Not the price, cost, or whatever. But actually, let's get into that improved cost thing. To maybe we'll learn something here. That's why I want to read this on stream, because I think this stuff is important. Yes, I heard something like that. I don't know if I can, maybe. Let's see. Introduction. Project Apollo is the most famous human spaceflight project in history, commanding resources approaching that of a wartime mobilization. The successful landing and safe return of American astronauts demonstrated the United States' supremacy over their Soviet competitors and created an enduring and historic cultural legacy. Yet, despite the notoriety of the Apollo project, Project Apollo, sorry, I read it backwards. There is no detailed, reliable data set detailing the costs required to achieve its success. Okay. I just want to get to the meat and potatoes. Okay. The structure of NASA's budget during the Apollo era. The accounting structure of NASA during the Apollo era differs significantly from the NASA of the early 21st century. Okay, guys, this let me just peep this. I just want to see how long this article is too. Whoa. Okay. All right, fellas, sit back, relax, and enjoy this narration. Let's learn something. At the time, NASA was divided into 3 major accounts, each appropriated separately. Research and development, which funded program activities, construction of facilities, which supported the design, construction, and equipping of government facilities, and administrative operations. AO, later renamed Research and Program Management, which provided staff salaries, travel, and other overhead costs. As a flight project, Apollo was primarily funded from the R&D account. However, significant infrastructure investments were made in support of Apollo, notably the establishment of the Manned Spacecraft Center and the Mississippi Test Facility, so that's Johnson Space Center in Stennis. Not to mention the expansion of the Kennedy Space Center. Implementing Apollo required large amounts of NASA's civil servant staff and management time. Proper accounting of the Apollo program requires these otherwise indirect costs of Apollo to be included along with direct R&D costs. 3. A survey of existing cost data. NASA reported the official cost of Apollo is $25.4 billion to the House of Representatives Committee on Science and Astronautics in early 1973. Though valuable as a total benchmark number, NASA's reports lack detail. It does not list spending by year, making accurate inflation adjustments impossible. The major components breakdown is too broad. There is no distinction made between the command service module costs and those of the lunar module, instead grouping such projects into a catch-all spacecraft category. Additionally, NASA provided no insight into the decision process for what was included in these categories, or even what was considered Apollo expenditures, which costs were excluded from this report. A more detailed accounting was included in the Apollo spacecraft, a chronology, volumes 1 through 4, excuse me. X is 10. All right. Later condensed as the table Apollo Program Budget Appropriations within the NASA History volume, Apollo by the Numbers, a statistical reference. Oh, sources. Thank you, God. It purports to list appropriations from every single component of the Apollo program between fiscal years 1960 and 1973, a significant improvement in detail compared to what NASA presents to Congress. However, there are a number of errors and data discrepancies that call into question the overall reliability of this data. Of these data? These data? Okay. First, there is a significant discrepancy in the reported costs, $19.4 billion compared to the $25.4 billion number reported to Congress. This is $972 million, or 4% less than the R&D costs reported by NASA in 1973. And $6 billion, 24% less than the total project costs. There is no effort to explain this discrepancy, though it is likely that this table only references R&D costs, as it includes no amount for facilities or administrative overhead. Second, the data is inaccurately presented as appropriations. The data is not congressional appropriations. Instead, it mostly lists obligations. Obligations are contract expenditures made by NASA using appropriate funds. Congress rarely appropriates at such a granular level. Additionally, the values for fiscal years of 1962 and 1973 list neither appropriations nor obligations. Instead, they list funds requested by the President's budget request, which may or may not have been provided by Congress. Third, there are significant omissions from programs prior to fiscal year 1964. For example, this table claims that no funds were spent on the Saturn I rocket before fiscal year 1964, yet the rocket launched in 1961. Whoops. Fourth, it contains an arithmetic error for NASA's total budget from 1960 to 1973. It should be $41.6 billion given the numbers provided, not $56.7 billion as written. Together, these issues raise significant concerns regarding the reliability of the cost data reported in Apollo by the Numbers. Howard McCurdy published several efforts to provide a finer-grained account of Apollo's costs, which improved on previous data by breaking out the cost of development and operations and defining costs for major sub-programs. However, like NASA's congressional reporting, these resources do not list expenditures by year. Additionally, McCurdy and his collaborators proposed an alternative accounting scheme for Apollo. For example, included the reported costs of the Gemini program, which makes it difficult to compare their totals to other sources. Okay. Given these limitations, an effort was undertaken to create a complete, reliable data set of Apollo's costs that includes both annual and program breakouts. Oof. Any economists in chat? 4. Methods and sources. Staff within NASA's financial office have attempted to reconstruct Apollo program's history with limited success. An undated, likely mid-2000s document found in the agency's historical archives captured one such aborted attempt, despairing that NASA's internal cost data is extremely sketchy and discrepancies typically are 15 to 20%. The discussion concluded that Data included in NASA's congressional budget justifications is a promising source to reconstruct the spending profile over time. What this document reveals is that there is no unpublished canonical dataset of Apollo's costs within NASA. While there may be high-fidelity data scattered through various NASA historical collections, the extent and locations of such documentation is unknown. Given the lack of high-quality internal data, the following decision process was used for assembling public data. Prioritize obligations reported in an annual congressional budget justification for R&D expenditures. If no obligations are available, use expected expenditures, or if no other data is available, requested expenditures. Okay, so let's see. Augment R&D spending with NASA cost reporting documents, internal or public, where possible, in particular for construction of facilities and administrative overhead. Given multiple datasets, prioritize OFCO Code B documentation and then publications closest to the original reporting years. And then define a consistent set of programs within Apollo to maintain a year-to-year consistency to maximize disruptions due to the accounting changes. Basically, this says that, they're going to fill in the blanks as best as they could, but they have to connect some dots here and there because their dataset is incomplete. Well, Hell Hydra, the thing is that when you have a goal-oriented program, if you have a goal-oriented program, it's about getting the goal done. Cost kind of takes a back seat to that, especially a bold goal like the Apollo program. Booster 7 has flaps? Kind of, goalie. There's kind of like 2 blisters on the bottom of it where all the COPVs are, and they're going to use that to generate lift. I'll get more into that in a second. I'm wondering if... All right, where's the... Okay. I just want to see where the budget stuff is broken down. But anyway, every NASA budget submission contains a wealth of data, including obligations for the fiscal year 2 years prior to the request. The 1965 NASA budget submission, for example, reports obligated amounts for the 1963 fiscal year. Obligations are legal liabilities of the government for the payment of goods or services made during a certain fiscal year, but may or may not be paid out in that same time period. Obligated amounts can be adjusted or go unspent, but any amounts returned to NASA will generally be reobligated rather than be returned to the Treasury. That basically says once the government gives NASA money, if they don't spend the whole thing, all of the obligation, it can go towards paying for other things. That's an occurrence that's not reported in public data. Hold on. Expenditures occur when an obligation is paid, an occurrence not reported in public data. For the purposes of this manuscript, obligations are considered generally equivalent to expenditures. The NASA History Office provided digitized records of the agency's congressional budget justifications during the Apollo era, which are available online via the Planetary Society's website. Additional 2 key financial documents were found in the archives, prepared in the advance of the 1973 congressional hearing, which report NASA's annual accounting of facilities, overhead, tracking, and data acquisition costs for 1961 through 1973. Throughout the period of Apollo, NASA changed its internal accounting practices and reporting, requiring a certain amount of editorial discretion to normalize costs over time. The majority of these normalizations are applied to the early years of the program, generally to match the more stable accounting structures used after 1964. Notable changes including separating the cost of rocket engine development versus production in the early 1960s. Development versus production, boys. Interesting. Incorporating the F-1 and Saturn development costs otherwise listed in the Department of Defense in 1960 and included Apollo-related advanced design studies and supporting ground development costs prior to 1962. Granular comments and notes highlighting all normalizations, editorial decisions, and data estimations are included in the final dataset, which is available online. Number 5. Results. A detailed accounting of Apollo's costs. All right, let's see what we got here. Guys. maybe a weird question, but is NASA a non-profit company? NASA is a no-profit company, Violent. They're a science research organization. They take money and they convert it to scientific knowledge and understanding. That knowledge and understanding can further American industry, or at least that's the idea. For instance, the idea of NASA to use commercial technology to move people to the space station, right? They started a program in the mid-2000s to come up with a way to hand low Earth orbit over to commercial entities once NASA decided to go back to the moon. This was originally established under Constellation, but I think we're seeing the fruits of that labor. The fruits of that program are working out pretty damn well. Yeah, see, with 2 of these missions being crew missions. Yeah. See what I mean? That's what NASA's supposed to be doing. They're supposed to come up with ways to... so NASA by definition, okay? NASA by definition is supposed to do... They're supposed to do scientific research and understanding, particularly when it comes to space and aeronautics, okay? So, for instance, like NASA was used as a way to figure out a pathway to the moon. And through that program, all the technologies that were required to take 2 guys and put them on the surface of the moon, or 3 guys out, 2 guys to the surface of the moon and back, all those technologies found their way into stuff that we use every day. Pushing the envelope like that in space makes you think about basic problems in a real different way. Nowadays, you can think about it like sustainability and stuff. So on the ISS, they can't just, flush the toilet and that water just goes into a reservoir somewhere. Like it just drains into a lake or whatever. You got to reuse it because there's no water. There's no other water. So filtration mechanisms, water purification, there's a bunch of things. Yeah. And the idea is that NASA does these awesome projects, or at least they're supposed to. They're supposed to do these awesome projects to help humanity gain understanding. Humanity, operative word. Understanding of, our place in the universe and try to make technology better for everybody. That was the reason why they started NASA. Eisenhower started it in 1958, based off of the 1957 decadal survey, or no, International Geophysical Year. Excuse me, that's what it was called, not a decadal survey. So, and once again, Violent, you got to remember, it's not just for Americans. Okay, anyone, anywhere in the world can go on NASA's image archive, can go to NASA's technical resources. Anyone can do that. You can go to it. I can go to it. Somebody in Russia could go to it. Somebody in Europe could go to it. Somebody in China could go to it. Yeah, no, it's for everyone, which is cool. Where would we be without NASA or its Soviet counterparts? Soviet space program, I don't know. I don't know, dude. Without NASA, I'll tell you right now, I pointed to the smartphone. There's a reason why I pointed to the smartphone. Violent, everybody here says that, this smartphone in the palm of my hand is like a bajillion times more powerful than the computer that landed people on the moon. I cannot say how much that is missing the freaking point. Everyone says this is a way faster computer. So 2 things. First of all, you don't need that powerful a computer to land on the moon. Okay? They had a computer that was basically a bunch of wires plugged into a potato and it got them to the surface of the moon. Okay? That computer was using rope memory, for Christ's sake. Computer hardware engineers are going, okay. Now, but what people don't, and this is the second part, what people fail to understand is that rope memory was a form of random access memory. This was the first RAM stick. No one had ever done that before. Digital processor, integrated circuit. No one had ever done that before. That was the first. That was the first full digital computer in how we think about it nowadays. Central processor, RAM, hard drive, that That is what made that whole thing. Now, don't get me wrong. It's not like they just had a hard drive dangling around inside of the Apollo spacecraft, right? It's a little more complicated than that. Without those pioneering technologies in digital processing, this would not exist. I can say that with confidence, guaranteed, 100%. We would not be where we are in the computing world if it wasn't for the Apollo program. It single-handedly put us about 20 years into the future, all right, in terms of like processing and computers and stuff. Like, look at how much stuff changed from 1965 to 1985. You think about 1985 in your head, you think like, you must whip it. You think about 1965, records, analog systems, tubes, transistor radios. That is a freaking huge difference. That's a huge difference in just 20 years. Even 65 to 75. If somebody from 1965 jumped to 1975, they would be very confused. They would be very confused. If somebody went from 1955 to 1985, they would also be very confused. See what I mean? Rote memory is not RAM. Yeah, yeah, W. Sorry, I'm dyslexic. I'm not. No, sorry. It's hard to rope all these ideas into one thing to get the point across. Sometimes I misspeak. My fault. That'd be really heavy. Weight has nothing to do with it. So, Marty did okay, just saying. Now, caveman, now take somebody from, you know, take somebody from some kid from actually 2015 and put them in 1985. They would get very confused. Yeah, they'd get very confused. So, yeah, Violent, it's not a non-profit. NASA is a government scientific research organization that's designed to give us net benefits. Like digital processing, water purification, Velcro. Actually, not Velcro, but Velcro is used in spaceflight a lot. There's all kinds of stuff, dude. The list goes on and on and on and on. Dude, it's pretty amazing. Like, once again, I can't tell you how much someone's missing the point when they say that this piece of equipment in my hand has 1,000 times more processing power than the Apollo spacecraft. That is totally missing the point. The reason why they have that in their hand is because of the Apollo spacecraft. That's the point. And that's what people don't understand. And that's part of the reason why I do what I do here. Now, with that being said, let's pump back into this cost. Take that into account when we look at these numbers, okay? The only tube that I have currently in my house is my old CRT TV. Tubes! Let's see. So, I'm looking... Let's take a look. So, this should be on somewhat of a bell curve with funding peaking in 67. Yep. The high point is in 67 for spacecraft. For the spacecraft. Where does the launch vehicle budget peak? Saturn V. Launch vehicle stuff peaked. Launch vehicle peaked in 1966. Where's that cost of facilities thing? I'll bet you that peaks before the Saturn V does. 64. Boom. Sinusoidal bell curves, man. Well, not sinusoidal, just overlapping bell curves. Think three-phase AC current. The facilities peak before the launch vehicle, because without the facilities, you can't make a launch vehicle, right? And then the payload peaks after the launch vehicle, because you can have a launch vehicle, you have a launch vehicle with no payload, who gives a frick? But you can't design the spacecraft until you design the launch vehicle. See that? Isn't that interesting? It overlaps. The peak for cost of facilities peaks in 64. Now, mission operations and support. When does that one peak? Look, mission operations and support peaks in 1968. That's right when they started launching people on the Saturn V. Operations, after spacecraft as well. Got to build the facilities first, launch vehicle second, payload to launch it third, and then operations fourth. Interesting, huh? What do I always talk about? Overlapping curves. That proves it right there. This is exactly what I'm talking about. That's how you set up a space program. And the crazy part is, from what we read about this damn document, they didn't even know that yet. That was just the way to do it, you know? Funny how that works. Interesting. Interesting. Yes, provocative. Yeah, cough, cough, Europa Clipper. See? That's how you fund a space program. This is how it gets done, baby. That's how you do it, right there. So, in SLS, we're in Apollo 64, or does it not correlate? I think this paper is trying to prove that, Bill. The annual cost of Project Apollo is reconstructed or summarized in Table 1, Table 2, 3, 4, and 5. Marginal per mission costs are included in Table 6. Inflation adjustments are discussed in Section 6 and presented in Table 7. Table 1 is NASA's annual obligations for Project Apollo, broken out by major program components. All values are in thousands of dollars. Italics indicate estimates. All right. Yeah, there you go. CO2 scrubbers, Celtic. Yep, boom. Direct result of this funding right here, man. Look, see these numbers? Even the total right here, 25. That's, what is that, $25.7 billion? Like, most of the stuff that was developed during this program, we still use. We still use, or it led to a better version of it. Like, that $25 billion has grown the tech industry into $1 trillion industry. This is the kind of stuff that NASA needs to do right here. This stuff. See this? Smart. Ugh. But Orion was designed for Ares, not SLS. Dude. Gaw, I will bet you that SLS's probably looks like an EKG. It probably has stuff peaking at the wrong times. I'll bet you. If it breaks it down, I'm wondering if they're going to do that. Table 2. Annual obligations for Apollo spacecraft and related programs. All values are in thousands. Data in italics are estimate. Dashes indicate no data. CSM and LM values for fiscal year 71 and 72 use historical spending ratios to estimate the relative obligations on each, though the total spacecraft obligation amount is actual data. Actually, before we look at that graph, I'm interested. I didn't get to see it. I didn't look at the thing in detail. I'm interested. Okay. You're designing, if we're going by spacecraft, okay, the Apollo program, you have your capsule and service module that make up the CSM, and then you have your ascent and descent stages, which make up the LEM, which make up the lander. Which thing do you design first? How much of that $1 trillion, EJ, how much of that $1 trillion business is greed? What? I don't care, Kane. That's not the point that I'm trying to... No, you missed the point. There wouldn't be, and it doesn't matter if it's greed or not. Yeah, people are greedy. Yeah, big whoop. Tell me something I don't know. But that industry exists because of NASA, dude. That's, you understand? It's correlation, man. So, we're going to develop the Apollo spacecraft, the LEM and the CSM and all their components. Which one do you design first? I'm going to go ahead and bet, and keep in mind, I don't have it open here. No hands. I didn't scroll. I still have table 1 up. I only looked at table 2 for a second. I'm going to guess, and I could be wrong about this. I'm going to guess that they designed capsule, service module, right? And then descent module, and then ascent module last. So, pod, service module, descent module, ascent module. I'm going to guess that that's how they did it. And also the coffee machine. The coffee machine was definitely always working, Hellfish. I have that on first-hand account from Jerry Griffin. I asked him, I go, during Apollo 13, what did mission control smell like? He said cigarettes and coffee. And I'm like, yep. I have that on tape, too. Well, tape, but you get the idea. All right, let's go. Let's see. Okay, spacecraft. The CSM, when did funding peak? Funding peaked in 66, okay? The lunar module, funding peaked 67. GNC, 66, because the GNC and the Apollo computer were in the capsule. Instrumentation and spacecraft support. That one goes up and then down and then peaks at 230 in 1970. Supporting development. I don't know what that is. Coffee. I take it these values are in thousands. They are. Yep. What about the budget for slide rules? Support development. NASA spent $53,000 in 1965 on slide rules. Now, that's probably not right. But look, check that out. Look. Capsule funding peaks before LEM funding. See? Methodical. And dude, they did. It's not like they even had the hindsight of being able to see this. The reason why I know so much about NASA funding and how it's supposed to work is because I've read about stuff like this. They didn't even know. They did it right. They did it right the first time, right off the bat. Well, asterisk that statement with the command service module, but smart, man. Okay, table 3. Annual obligations for the launch vehicles. Well, this one should be easy. Which one do you think goes first? Launch vehicles. The options are Saturn 1, Saturn 1B, Saturn 5, and then engine development. Which one do you think goes first? This is an easy one, guys. You better get this. What peaks first? Saturn 1, Saturn 1B, Saturn 5? Which one goes first? Saturn 1? Engine? Banana? Boat? Shuttle, obviously. Okay, I'll take the sarcasm as you guys know the answer. So, I'm going to guess that Saturn 1 comes first. And then, you'd think that Saturn 1B comes second. But I would say that the Saturn 5 funding peaks before the Saturn 1B does. There, I said it. I'm gonna go ahead and say that that's what's going on. So I think they did Saturn 1 first, Saturn 5, then Saturn 1B, and then engine development probably stayed at a consistent throughout the whole program, if I had to guess. Let's see. So Saturn 1 peaked in 1963. That was first. Saturn 5. Its peak funding was in 1966. Saturn 1B, its funding peaked in the same year. Interesting. One program ramps down, the other ramps up, but it also is ramping up with Saturn 5. And then engine development ramped up and then kind of, 136, 66, 66, 33, 49, 20. Yep. Interesting. Saturn 1B and Saturn 5 peaked both in 66. Okay, what's this next one? Annual obligations for mission support and operations. Okay, mission support and operations. This one should be easy because it should peak when they actually flew people to the moon. I'm going to go ahead and guess that this probably peaked in 1970. Let's see. Mission support and operations. They spent $100 in 1960. Oh, yeah. Yep, $100 doing program development studies. Mission support, 1968. Mission operations, 1969. Mission support and operations, 1968. Ah, interesting. Due to the short time frame of the goal, political will was there to make it happen. Yep. Yeah, it's in thousands, guys. That's 100,000. It was a joke, but yeah. I said it was in thousands already. If you think I just Freudian slipped. No. I said it was in thousands literally like 5 minutes ago. It was a joke. It was a joke, guys. Relax. Annual obligations for all indirect Apollo costs. All right, let's just keep going. Annual indirect construction of facilities. 1964. Yep. The VAB was done by mid-65. So was Complex 39. Research program and management. 1967, 68. Tracking. Well, during the operational missions, that probably stayed really high, and then it probably tanks in 1972 when the last Apollo mission came through. Yep. Yep. Marginal costs per crewed Apollo mission. Which one? Here. Which Apollo missions do you think carried the most cost? This is an interesting one. I don't know the answer to this, but I have a pretty damn good guess. Which Apollo mission do you think was the most complicated? 4, 8, and 11. Four, 8, and 11. Ian, those are pretty good guesses. All right. I'm going to guess Apollo 15. Okay? I'm going to guess Apollo 15. Just because. Let's see. Let's see what happens. 13? 13 would also be a good guess. I'm going to guess Apollo 15. Matt, you're going to guess Apollo 15 too? Kev says the J missions. All right, let's see. Let's see. This is cool. I like this. This is really neat. All right, let's take a look. Saturn 1B for Apollo 7 was 45. 8, 185, 185, 185, 185, 185, 185, 185, 185, 185. Let's see the totals. Apollo 9 is the highest? Nope. Apollo 11, 2.9. Apollo 12 was 3. 15, 3.6. Hey! Hey! All right! Yeah, it's 15, man. That was the most complicated one, and that was the first time that they did it. That was an extended duration mission. A lot of people don't know that 15, 16, and 17 spent 3 days on the moon, each one of them. Neil and Buzz, during Apollo 11, spent 20 hours on the moon. They landed, they slept, they went outside, got back in, slept again, and then left. 17? Oh, 17 is the most expensive. Damn. Well, okay, so let's think about that. It's not by much, but why? Why do we think 17 was the most expensive? '17 had the most experiments. That's right, Bran. You got it. Hey, Chops. Nope. It had the most experiments on it because, so there's a trivia question here. The reason why 17 is expensive, I actually know the answer to this question too. I thought that 15 would be more, but that makes sense that 17 is more. Now, the reason why it's more is because, one, it was the last Apollo mission. Everybody knew it was the last Apollo mission, so everybody they jam-packed that mission with as much science as possible. 2, when they realized Apollo was getting canceled, they took the Apollo applications program and tried to put as much as they could into the Apollo missions, which feeds back into 1, which means that 17 had a bunch of stuff that would have been done on like 18, 19, and 20, all jammed into one mission. Yeah, Jack Schmitt and Gene Cernan did a lot of work in Taurus Littrow. Yep. And the first U.S. civilian astronaut, Jack Schmitt. Yep, still alive. Yep. First geologist. He was the only scientist that made it to the moon out of 12 guys. He's the only scientist. Everybody else was test pilots. What about inflation? I see a lot of people saying inflation. I'm going to go ahead and guess that you guys weren't here when I was explaining when I did the excerpts at the beginning of the document. This is taking into account inflation. That's the short story. It's taking into account fluctuating inflation and averaging it. Yeah, no, it's all good, Alta. It's all good, man. That's why I explained it. Probably good. I mean, Alta, dude, the way I look at it, If I see one or two people mentioning it in chat, that means there's like 30 lurkers that are also wondering the same question. So it makes, you gave me an in for explaining it one more time, which is important. Yeah, 17. But see, look at these J missions. 3.6, 3.6, 3.69. Yeah, see, 17. That was a complicated mission. Dude, 17 went, I don't even know. They went like 5 miles away from the landing site with a lunar buggy. Like, they traveled like the length of Manhattan away from the lander. Can you think about that for a second? I said they went on a road trip on the moon. They went on a damn road trip. It's actually pretty crazy. Think about that for a second. 5 miles away from the lander, from your only way home. And if you blow a tire, you gotta walk. The tires, that's not how they work, but you get the idea. Do you think Artemis will capture the public imagination like Apollo? Ark, I think what the Artemis program will do is recapture it. Yes, I do. Do you know why? Because we'll get high-def pictures of people on the moon. We'll get high definition, live streaming. People will be able to see it in real time. You know, it won't be some distant memory 50 years old that only a quarter or a third or a half of the population remembers. You got to remember, the vast majority of people that are spaceflight fans nowadays haven't seen anybody go out of low Earth orbit, myself included. We don't know what that's like. We've never experienced that. It's really annoying, but we will soon. We're going to get 2 Earth rises on Artemis 1. Yep, I'm so excited to watch Vic walk out on the moon in 4K. Ian, I really think he's the guy. Vic's the guy. He's the guy. I'm pretty damn sure. Him and Johnny Kim and like Ann McClain and who else? Kayla Barron, the woman that's up there right now, the sub commander. Oh yeah, no, those are the ones. Jessica Meyer, yeah. Johnny Kim is my hero. And Vic is a Chad. He's the Chad. He's a Giga Chad. Giga Chad astronaut. Him and Johnny. Yeah, I agree, Ian. I agree. I'm with you on that one. Yeah. There's some pretty cool individuals on the Turtles are my favorite astronaut class that I've seen in a while. There's some really talented people on that team. Don't read astronauts' resumes. You'll feel really bad about yourself. Don't read their resumes. You'll be like, oh, I didn't realize I was this inadequate. Dang it. Astronaut Pete Davidson. No, that's something different. Nicole Mann, yeah, she's pretty cool, Novus. Yeah, we got a lot of really talented folk in there. Is Johnny Kim the Dr. Navy SEAL astronaut? Yeah. All right. I brushed my teeth today, Johnny, so there. All right, man. Damn. It's a freaking Chad Panda, man. That guy's so cool. Victor, too. Victor has like 5,000 hours at the seat of like F-18. He has like 500 carrier landings or something. Navy test pilot, if I'm remembering right. Dude has like 5 kids. It's just absolute Giga Chad. Just Giga Chad all day. He's just chatting it up. I'm like, all right. I operate a partially successful Twitch stream, Vic, so there. That's something you haven't done. He probably could do it and probably could do it better than me. It's fine. That's all right. Well, Violent, I think that's what this paper is trying to say. I think they're going to rope this all in to SLS at the end. Yeah, Ian, checkmate. Vic hasn't written for NASA spaceflight, now has he? Guess what, fool? You want to be Vic, don't lie? No, Grim, I don't do that. I don't envy other people like that. That's I look up to Vic. I don't envy him. I look up to him. It's the right stuff, man. I look up to Victor Glover or Johnny Kim like how I look up to Neil Armstrong or Buzz Aldrin or something. I look up to them. Like, this is where the bar is set, man. Let's go. Let's go there. You know? Take that mentality, take that standard of excellence and try to apply it to my work. It's very inspiring stuff. I get inspired by most astronauts. It's very cool. They're very cool individuals. You know, seeing astronauts do that, you know, I don't look at them and say, oh, man, you get to be an astronaut. Like, I say that, well, I brushed my teeth. I say that as a joke. You know, I look to these people, and it's very inspiring to me. It shows you what can be done, what can be accomplished. What's the difference between them and me? You know? Not in terms of, like, I mean, astronauts are way smarter than I am, like, way smarter than I am. But what I'm getting at is, like, look at what someone can achieve if they just get some pep in their step. You know what I mean? Like, it's very inspiring. I don't envy by any means. I respect and I really look up to it. They're pretty damn good role models. I'm not envious. Dude, would I want to go into space? Yes, absolutely. Absolutely. Would I go to the moon? Yes, absolutely. If NASA called me and said, we need you to go on a mission in 2027, I'd be like, dude, I'm there. Where do I sign? Where do I go? Let's go. You don't even need to freaking pay me. It's fine. Just pay me for food and I'll be good. That's it. Like, that's all. You should do an Artemis 1 end-to-end in KSP. I don't know if we can nail the distant retrograde orbit, Novus, but I'll think about it. Yeah, you know, Predominant, you're not gonna like this next part, but I also, as an American, I look up to my fellow Americans like that. Like, these people they came from the same country that I did. I'm really freaking proud of that. That really makes me happy, man. I know you're not into the whole, liking, you know, the U.S., like, American stuff. Don't get me wrong. We're not perfect. I get it. But it's very inspiring stuff, you know? It makes me happy. It makes me happy that, you know, these people came from the same place that I did. Some of them actually are from Massachusetts, you know? Like, so some astronauts actually came from the same place. Like Sunny Williams, she grew up in the next town over. I've driven by, like, the schools that she went to. I played high school football against that high school. Like, I know where that is. That's something tangible to grasp onto. It's really cool. That's really inspiring stuff. That people came from the same place that I did, and these people are, like, going off into space and going to the moon and stuff. It's so cool. It's so cool, man. Like, how ridiculous would it be to see somebody from your hometown walking on the moon, or even your country? That's so cool. It's so inspiring, man. It makes me so happy. It makes me so happy. In a world of just crap news, there's, like, this stuff stands out, man. It's just on another level. Yeah, I'm kind of with you on that one. Story Musgrave is from Boston. Charles Precourt, the guy that runs Northrop Grumman, yeah, he's from here. Sonny Williams is from here. Story Musgrave is from here. Stephen Bowen, I think, is from Massachusetts as well. There's a lot of astronauts from Massachusetts. Yeah, he's from Cohasset. Yeah, South Shore. Pity. No, that's an inside joke. I think it would be extremely cool, ML crawler integration along with flight. Novus, I went through trying to make a crawler transporter, and I got the treads working, but it's... Building a CT in Kerbal is a challenge. That's a really hard thing to do. That would require, like, a full week of Kerbal with, like, my direct, like, all Kerbal the whole week. Like, I'm talking 8 hours of Kerbal every day to get that crawler transporter up to snuff. And I'm worried, because even if I did do it, it would probably be like 500, 600, 700 parts for just the crawler. It's complicated, man. It's a complicated piece of equipment. They must want to get as far away from Massachusetts as they can get. Yeah, right. Yeah, you're not wrong. Nice, Linprod. So, like all Kraken tech, it's unreliable. No, Rocket Guy, I think we could dial it in. Especially with the advancements that I've made with the VTOLs and single vessel Kraken tech, I think we could dial it in. I think I could get it to work. Yeah, I'm pretty damn confident that I could. I'm worried about the part count. Nobody's going to care if it actually takes me 11 hours to move a rocket to the pad in KSP. You know what I'm saying? Yeah, you can predict the failure modes, Rock Guy. It just takes time because there's no other way to predict the model. You just have to do it in Kerbal, so you have to do rapid prototyping, which is what Kerbal's gameplay loop is. So, no waterfall testing. I have 5 words for you. Vice Grip Garage Model A. Oh no. Somebody already told me to go and check it. 32-player railroads. Open up a session and get everyone in there. Go, go. Yeah. I'm not sure Violent when KSP2 is coming out. Anyway, let's go back to this. All right, what's the next one? NASA's obligations for Project Apollo and its major hardware programs. So what costs the most? Saturn V. The Saturn family of rockets is what costs the most. Spacecraft is in a close second. That makes sense. The spacecraft, despite being one small part of the ship, is the most complicated by a long shot. I'll give you a good example. The shuttle's more complicated than the SRBs it flies with by a pretty significant margin. That's probably an extreme example, but an example nonetheless. R&D, $20.6 billion. Total indirect cost, total Apollo. Yeah. Yep. Yep. Yeah. You know what's the crazy part is, guys, and I'll say this again. I've said it plenty of times on stream. I'll say it one more time. These numbers are nothing compared to the capability. What the real travesty here is we spent all this and only went to the moon 6 times. That's the real travesty here. These numbers are about what it costs to make a freaking rocket that goes to the moon. Like, we use these as a baseline, right? Like, that's what it costs. There's your baseline right there. It's expensive, man. Let's see. So this is adjusted for inflation here if everybody wants to see it. So total Apollo expenditures, and this would have been 1961 through 1973, so 12 years, puts it at $257 billion. Who went to the moon 9 times? Yeah, 13, 8, and 10. Yeah, that's correct. Yeah, I know. So what's unsustainable and what's not, Shaw? I'm interested if they draw the conclusion. I want to see them compare it to SLS. I want to see if they do. Inflation adjustment is far from an exact science. So $257 billion over 12 years. That's expensive. That's expensive. That's expensive. What? Here, hold on. Let me just see something here. 21.4. That's funny because that pretty much is NASA's budget right now. 257 over 12 years, $21.4 billion a year. Let's round up to 20. Let's just say 21.5 billion. NASA's budget is 24. Yeah, that's actually about right. Huh. But keep in mind, these numbers change over time. It's not 21 billion a year. One year it was like 100, and the next one it was like 10. You know what I mean? It's a bell curve. It always is. Oh, here. This is it in bar graph form. Let's see. Construction, tracking, and overhead. See? The VAB stuff. Interesting. Yeah, W, that'd be nice. That goes back to what I say. That goes back to what I keep saying, W. NASA doesn't need the military's budget. They really don't. Double it. That's it. Just double it, you get another Apollo program. Just double, which is still less than 1% of our annual spending. Less than 1%. We're talking pennies on the dollar to send people to the moon. It's ridiculous, right? As a taxpayer, that's kind of annoying. It's kind of annoying. Yeah, 1.5 times would be great. 2 times, easily moon colony. Moon colony. 2.5 times, Mars colony, easy. Seriously. But I want to show you guys something. Check this out. If you look at the budget from 64 to 68, okay? See this right here? You see how the budget basically doesn't go up? So there's the start of the program, right? And then there's the conclusion of the program, which is really annoying. The funding should have stayed this way, but once again, I get it. It doesn't really work like that. The operations funding would have, like, yeah, see? Take a look. So operations in 1964 was nothing, all right? It's mostly development. It's mostly building the VAB, working on the Saturn, working on the spacecraft, developing everything. And then in 67, by 67, they had the entire design figured out. Look at how operations balloons after 1967. Look at how much of it was mission control. Houston, we got a problem. Like, that's what it is. See? And I think that 1968, 69, and 70, not 71 and 72 so much, okay? Ignore those for a moment. 68, 69, and 70, like, dude, we completed the objective right here. So 69, 70 are probably more representative of what the operational cost of the Apollo program really would have ended up being. Look, by 1972, NASA's budget was a quarter of what it was. They were still going to the moon. They were still going to the moon, and not only were they still going to the moon, they were still going to the moon 3 times a freaking year. Because Neil Armstrong and Buzz Aldrin set foot on the moon in July of 1969. How many people realize that Apollo 10, the mission that went to the moon before that, was a couple of months earlier? And not a lot of people realize that Apollo 8 was in December of 1968. That means between December and then after Apollo 11, in the fall of 1969, Apollo 12 went to the moon. So between December 1968 and December 1969, we went to the moon 4 freaking times and landed 3 of them. Well, 2 of them. 11 and 12. Crazy, huh? So that's much more representative of your operational budget right here. See what I mean? NASA's budget got axed, but even if it did, it would have come down anyway. And just operating the Saturn V and not developing new versions or anything like that, we could have just kept going to the moon 3 to 4 times a year. We could have kept doing it for the next 20, 30 years, no problem. Isn't that crazy? That's ridiculous. Well, Liam, you wanted a space news. I saw what you said when I was playing Planet Crafter. You wanted a space news. You got a space news, boy. Dude, 4 times. 4 times to the moon in basically in the span of 12 months. That's unreal. And then we carried that cadence to December 1972. Oh. See what I'm talking about? Look, even the operations price, by the time, while we were still maintaining that cadence, we could have just kept launching people to the moon. Look at 73. Unbelievable. And no, we got to do the Apollo Soyuz test project. Screw that. Like, you know why there's a huge gap here? Because they shifted all of this to fund the space shuttle. That's why. The NASA's budget basically went straight from 1971 onward. It was right here. This was the approval of the space shuttle, and that was the start of the space shuttle program. So one program ramps down, the other one ramps up. But if we were serious about doing that, the space shuttle program would have started right here and it would have ramped up right here instead of over here. Once again, you should ramp one up and the other program should peak right after the other one. See how the funding stays pretty fixed for 4 years right there? 4 years of just good spending gives you the dexterity to put boots on the ground on the moon. See what I'm talking about? It's crazy. The costs go down. This is the stuff that I base my theories off of when I tell people that SLS costs will go down, because they will. Well, let's see. Well, actually, I'm wondering. Now I'm wondering what their conclusion was with this. Yeah, I know. Screw me, right? Here we go. Here. All right, I want to read this. A political interest is the upward growth of the Apollo missions' marginal cost, which steadily increased over the program's lifetime. Table 6. The single G-class mission of Apollo 11 was reported to cost $355 million for the spacecraft, experiments, and launch vehicle. Adjusted for inflation, that's a couple $2 billion. This increased to an average of $389 million for the subsequent H-class missions, jumping to an average $447 for the final set of scientifically rich J missions, ending with 17. So basically what the chart said. Adjusted for 2020 dollars, Apollo's lunar surface mission started at $2.9 billion and ended up costing $3.7 billion apiece. Yeah, remember those operational costs? How they're going to balloon over time for Europa Clipper? Yeah. There you go. That's just for spending 3 days on the moon instead of 20 hours. That's the difference between the missions. Yeah. Yeah. Okay. Try doing that for like 10 years. Yeah. The costs are going to go up. They're going to go up a lot. Where was I? I was down here. The time frame in which the price grew, 1969 and 1972, was also the period when the U.S. public grew increasingly sour on expenditures for spaceflight, and when NASA's overall budget decreased by 17%. This tension between the growing cost of Apollo missions and its collapsing public support emphasizes the program's unsustainable political design. Yeah, that's what they mean when they say Apollo was unsustainable. It wasn't unsustainable economically. It was very sustainable by economically. But the Apollo program is a damn good case study into why NASA's budget ultimately is subject to political will, which is tied to public perception. And what sustains political will when it comes to spaceflight? Goals and deadlines. I've been saying this for years, man. Interesting. Huh. I'm feeling, I don't know about you guys, I'm feeling pretty frickin' vindicated from this paper thus far. Yeah, pretty much confirms everything that I've been saying for the better part of a decade. Oh, God. I don't know. Actually, now I'm getting a little bit of anxiety from that. I'm not going to lie to you. Oh, man. All right, let's keep going. An example comparison to modern programs. Uh-oh. I really hope I'm wrong. I really hope I'm wrong, because if their conclusions are the same conclusions that I come to, that's not this next part's not going to be pretty. Here we go. Dive in, boys and girls. Let's do this. An example comparison to modern programs. At the time of writing, NASA's Space Launch System rocket is nearing its first demonstration mission after a decade of development. The program is marred by significant delays and cost overruns. Unlike the Saturn V, which was ready in time to achieve the lunar landing goal by the end of the 1960s, the SLS program schedule threatens the 2024 lunar return goal of Project Artemis. Now, there wasn't a pandemic during the Apollo program, dicks. What? Oh, say that out loud. With the annual costs for the Saturn V, we are in a position to compare the annual resources provided to each program. Chart 2 demonstrates the dramatic funding advantage enjoyed by the Saturn V compared to SLS. $6.6 billion was spent on the Saturn V for Apollo, approximately $66 billion in 2020 dollars. Spending on SLS, by contrast, is projected to just reach $27 billion by its first crew launch in 2024. Save $30 billion. We didn't save $30 billion, fellas. We saved $30 billion now to spend $50 billion later. Yep. Okay. We're 1 for 1. Ow. Nominally, this represents a significant improvement in development costs from a human-capable vehicle. Bingo. Absolutely true. Here. Let's see. Yep. There's the bump that it got when Jim came into office. Year 10 is, yeah, there's the bump. I don't know what their starting year is, actually. Let me take a look. 2013 to 2022. So 2013, 2014, 2015, 2016, 2017, 2018. Yep. Okay, so that's not the bump. There's the bump right there. But some good news from this. This is when Jim started. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 20, this is where Bill started, and it went up again. Not bad. Same line for the space shuttle if we compare, also Constellation. Well, Rocket Guy, Constellation was supposed to do this because they knew that this was the right way, and they knew that the shuttle was the wrong way. But because we were in the middle of recession, everyone got sticker shock. And they gave us that instead. Like I said, you save $30 billion now to spend $40 billion later. See what I mean? See? Look at that. Remember, guys, remember, okay? Look. Apollo, right here. See this? That little thing right there is your true operational cost. This is how much it costs just to, not to develop much, right? Just to send people to the moon, right there. See what I'm talking about? And that was on the first, that was your first attempt. See what I mean? And then after that, it goes down. So this is like 68, 69, 70, 71, 72. So right in here, there, see where it goes down? Operations go down all the time. Once development stops and you just fly operational missions, you could do it for nothing. A good example would be the guy running Roscosmos. They've been just running Soyuz for a long time, and the price, they were able to compete on price with a rocket that's 70 years old almost. Well, they could compete on price. Something happened about a month ago. I don't know. Someone's gonna have to tell me that. I don't know. Something happened about a month ago, and they haven't been able to compete since. I don't know why. Something happened. So then we got Journey to Mars, and nothing changed. Yep, they literally just repeated themselves. Interesting. All right, so we're 2 for 2 on that one, Rocket Guy. Operations are cheaper than development. 2 for 2 on that one. That's what NASA's Systems Engineering Handbook says. Funny how that works. Okay, annual obligations for the Space Launch System and Saturn V programs. Okay, that's what that chart is. However, as Chart 2 demonstrated, the SLS is another example of designing to cost. The designing to cost paradigm of NASA's post-Apollo human space flight projects. Unlike the Saturn V, which demonstrates a classic cost curve development cycle, SLS was provided with flat funding through its development regardless of program needs. This was a function of politically motivated resource allocation, one that lowers annual costs and shifts expenditures into the 3 for 3. I really don't like that I'm right on that one. That's not good at all. Where'd how a flat development curve pushes out your schedule. Yeah, it's funny how that works. Novus, I don't like that me and Rocket Guy are right. I really don't like that. I don't like this at all. I really don't like this at all. Is there a link for this? Sure. Yeah, if you guys want to look into it, I'll keep going. Yeah, that's pretty neat. That's not neat at all. This is a function of politically motivated resource allocation, one that lowers annual costs and shifts expenditures into the future, increasing the overall cost of the program. The Saturn V project ended after 13 years. SLS is planned to launch its first crew after 13 years and is projected to continue indefinitely into the future. Fuck. Excuse me. This is further reflected in comparing the marginal cost of the Saturn V and the SLS. The average build cost of a Saturn V is reported to be $185 million, or approximately $1.3 billion in 2020 dollars. The SLS's per launch costs are reported to be anywhere from $876 million to $2.2 billion, depending on how NASA accounts for related overhead costs. The $2.2 billion is because of development. Because the development is freaking long. So while SLS may cost less to develop than the Saturn V, as one might expect, given it is restoring, not creating capability, its marginal costs are likely to be higher due to its under-resourced design phase. If McCurdy's paradigm continues, the SLS will not just carry forward the hardware heritage of the space shuttle, but its high operating costs that stifled future program innovation as well. But SLS is doing well, right? Like, we're getting moon launches soon, right? Did I miss any bad news? No, Cerebral, here's the thing. Yeah, the costs will go down. But the costs will go down if we buy more SLS missions. We need to buy more of them. That's how you get your marginal costs down. Usually that ends after vehicle development. The thing about SLS is that Block 1 is not going to get us anywhere. You need Block 1B to get any useful stuff out to the moon. But then again, there is Starship, so that's another story. But, you know, they didn't even design the lander. I've always said that the ICPS was a bad idea. It was a bad idea. It was a terrible idea. Just a terrible, terrible, terrible thing. You spent all that money to develop a vehicle that does nothing. It can send people to the moon. It can't circularize them in low lunar orbit. It gets them to rectilinear halo orbit, and that's it. And then you get a capsule there. Now, keep in mind that SLS is supposed to work with Gateway. Gateway is what makes that all work right, because now SLS and Orion can build the Gateway and then bring lander parts out with the form of SLS Block 1B. But the problem is that SLS Block 1B hasn't been developed yet. So when does development end? Per NASA's missions, and what they have kind of ironed out, not really like fleshed out completely yet, it'll end with Block 2 development when Artemis 9 rolls around at the end of this decade. That's not good. And you know, like, this is where critics of the program come in. Now, like, people say, oh, it's not, you know, this isn't going to work, this isn't going to work. That's probably what the Investigator General was talking about when he said it's not sustainable. But I will go back to what I said before. It's not sustainable. Compared to what? This is a good comparison to the Saturn V. Is there anything that it compares to now? Remember, we're restoring capability. If we want to duplicate and elaborate on the Apollo program, we have to at least get back to doing what the Apollo program did, and then we can pick up the slack from there. And when is that slated to happen? Around the time SLS Block 2 or Block 1B starts flying, sometime in the next 5 years? See what I'm talking about there? What does it say? What are you comparing it to? You can't compare it to the Saturn V. Totally different program. You can't compare it to anything. It doesn't work that way. So, what I've been basically saying is that, look, SLS is better. It's fine. At least we have something. It's better than nothing. But you really want to get this program to be real sustainable, you got to up the frequency of flight to lower the marginal cost per vehicle. It's going to take a while for that to happen, but we'll get there eventually. I don't know why NASA just doesn't follow their own standards. You don't make a design constraint on yourself before you begin engineering development. NASA limited themselves so big by pushing SDLV tech. Well, yeah. I mean, Rocket Guy, here's the thing, all right? The politicians that are controlling NASA's purse strings want jobs in their district. They want to keep jobs in their district. I understand that. I get it. You know, like I said, it's better than nothing. However, you don't say, oh, SDLV, shuttle-derived launch vehicle, is constraining them. Well, Constellation was shuttle-derived, and that would have worked just fine. And on top of that, it would not have cost this much. There's no way it would have cost this much. You know why it wouldn't have cost this much? Because you got all the technical personnel. You don't have a brain drain from NASA in 2012 like what actually happened, right? Using a shuttle-derived launch vehicle is fine as long as you carry over personnel from the SDLV. If you carry over the tech but not the personnel, costs are going to skyrocket. Oh wait, that's exactly what happened, right? Am I thinking about this wrong? A shuttle-derived launch vehicle wouldn't have been a bad idea it's not a bad idea as long as the programs overlap. You ramp down the shuttle program and you slowly move people from one program to the other. One race, Discord asks, what time is it? Oh, it's 9:30. I'll conclude this and then we'll go. So, science is the only part of NASA decision making. God, Joe, I wish you were right. Oh man, I wish. That would be really nice. Yeah, because violent, they're too busy doing something. I don't know what the frick they do to you. I don't know. Anyway, conclusion. Let's see what their conclusion is. A detailed year-by-year reconstruction of Apollo's cost was compiled using data NASA reported to Congress between 1960 and 1973. The data was normalized to maintain accounting consistency over the project's history. Marginal costs of every crew lunar landing mission were also included. Detailed notes and raw data are available online at both the Planetary Society's website and Elsevier's Mendeley data hosting service. According to this method, the total cost of Project Apollo amounted to $25.8 billion, a figure closely matching the official reported cost of the project. The reconstruction is an improvement over existing data. It includes detailed annual costs for every major hardware development program related to Apollo. This additional fidelity allows for improved inflation adjustments using NASA's New START Index for research and development work and the Production Workers' Compensation Index for construction projects. The cost of Apollo was calculated to be $257 billion in 2020 dollars. This detailed cost data set and improved inflation calculation support improved comparisons between Apollo, the one successful data point of a crew lunar landing, and modern efforts to return humans to the moon. Declaration of competing interests. The author declares that they have no known competing financial interests or personal relationships that could have appeared to influence the work reported on this paper. Yeah. Like I said, pretty much says exactly what I'm saying. This isn't the best, but it's good enough. It's not the best. It's not the best way to do things, but it's pretty dang good, and it's better than nothing. That's for sure. Because we almost got nothing. You know. We almost got nothing, dudes. It was that close. It was that close from getting nothing. You know. Interesting. That's a good paper. Novus, Rocket Guy, I think that pretty much confirmed everything that we were saying for the longest time. It's very interesting. Who wrote this paper, just out of curiosity? Casey Dreyer, Planetary Society. Yep. Pretty much confirmed everything that I've been saying for a very long time, guys. And I don't get me wrong. This is my independent thinking. I'm not regurgitating anyone's thinking. I analyze just like this paper does. I've been studying these costs for years. It says exactly what I'm thinking. It's going to take a while for SLS costs to come down, but they will come down, just as I've been saying. They will come down, but a real good way to get them down is to not go to the moon once a year. Yeah. Believe it or not, like, as you know, we said that the Constellation program saved 30 to spend 50 billion later, right? If we spend an extra 5 billion now, we could end up to build like block buying SLS. The costs could go below the Saturn V. Easily go below the Saturn V. Like, very easily. Yeah. Heck, the cost could get lower than the space shuttle. I think that's a pretty good conclusion right there. Yeah, it's a great paper. Really happy this was linked today, guys. That was fun. I enjoyed it. I didn't like that I was right, but I enjoyed it. Oh, also, just as a follow-up, just in case you didn't want any more bad news, the FAA intends to issue the final programmatic assessment for the SpaceX Starship Super Heavy project on April 29th, 2022. You're welcome. We'll go over Starship stuff tomorrow. They moved Booster 7 out today, which is cool. But yeah, I hope you guys enjoyed that space news. I hope you guys enjoyed it. That's the kind of data analysis I do off stream because I'm a loser. This is the kind of stuff I comb through. You know? This is the stuff that's important to understand. See you on the track. Yep. Interesting, huh? It's pretty interesting. And you like one. No, I already had a conclusion. I could sit here and rant about Constellation more all I want to, but yeah. We'll talk about that for another day. I hope you guys enjoyed that space news. We are going to race a full race at Atlanta Motor Speedway now with the NASCAR Cup. So that should be fun. Let's jump in. We got 1.5 mile racing, and I know people are gonna say, "Oh, 1.5 mile's boring." It's not boring to race. It's really fun, actually. Are your bowels sufficiently prepared? I think I'm good, Cerebral. That's a good question. I think I'm good this time. So, fellas, we're gonna switch over to EJ NASCAR or EJRA NASCAR Cup at Atlanta.